Good day, my name is Robert Magee and I'm here today to talk about getting started with the Houdini engine for Unreal. This is technology that allows you to work with Houdini under the hood inside the Unreal editor. This presentation is designed for game developers who are new to Houdini, who want to learn about the Unreal Engine plugin that we have for working this way. So the agenda today is we're going to start by talking about procedural assets for artists and level designers. So these are assets that exist that you can use in Unreal to create game art. The second part is going to how you create your own versions of those assets using Houdini and its node-based workflow. And the third thing we're going to do is learn how to install and license the technology and just a little bit about how to set it up properly if you go and work with this on your own. Okay, so the first thing is assets that already exist and how to work with them in Unreal. And we're going to start specifically with a series called the Unreal Starter Kit, which is available on the SideEffects website. You go to the Get menu under the Content Library, and this is a collection of assets that each come with a tutorial, and you can learn how to install them and work with them, and we'll take a little preview of a couple of them today. So here we are in Unreal, and there's the Houdini engine menu, which means it's been installed properly, and we start a session there. And then we have a folder here with the starter kit. So I downloaded it and installed it into this project. So here's our first asset, which is a tree. Now at first you look at it and go, okay, maybe this is just like any other tree. You bring it in, and it's a sort of a static asset. But this is a procedural asset. So what that means is you've got control over different aspects of it. Like for instance here, we can grab these points on this curve, and by manipulating them, we can change the look of that asset right here in the 3D view. So the way that this works is that as you manipulate an asset here, under the hood, Houdini Engine is processing Houdini and giving you the result that we have here. So this is something that works inside the editor here. It's not a runtime. You don't have the ability to manipulate these things in runtime, but they do help you as you're creating your levels and designing your art. So here you see some parameters that are available. Like for instance, we could get rid of the leaves and just work with a tree that has the stalk here. So let's go and put another one in. Let's bring in the wall tool. So again, this comes in looking like an ordinary asset, but we have a whole bunch of options which we can get access to here on the menu, and you can see these parameters here. So the first thing we're going to do is we're going to work with the stones instead of the plain one. Let's go and add a door. So that allows us to put a door into the middle of this. We can change the overall size. So all this, again, you're manipulating it here in Unreal, and under the hood, Houdini is being processed to generate the geometry the way that you need it. So now we're going to go into the border, and we're going to change the border to stone to match what we've been doing, we did with the rest of it. And we don't need it everywhere. So let's get rid of from the bottom, from the right, and from the left. So we only have it at the top and around the door. So all of these options are built into these digital assets to allow you to customize a particular asset to the needs of your game, rather than it being a static asset, which you'd have to go back and remodel if you wanted something to be changed. All of that's here. We can even bend this wall. That's a built-in feature of the asset, and then we can sort of rotate it into place, move it into place, and there we go. We'll have a nice little sort of round wall in the corner. And as you're developing your level, at any point you can step back and continue to make edits in this. You put it in place, decide, what, I'd like to make it a little wider, and maybe make it almost as tall as the wall that we have here, and then move that into place. Now, as an Unreal artist or level designer, I'm working with this tool. I don't actually have any idea. I mean, if it didn't have the little logo there, Houdini Engine, the fact that Houdini is involved in this, that's irrelevant. I mean, at the moment, this just feels like I'm working with Unreal. I'm just adding and enhancing my experience in Unreal using these procedural assets. And that's good, because it means that the Unreal level designer or artist is able to use Houdini Engine without changing the way they work. They don't have to learn a new interface. They don't have to learn Houdini at all. They can just take advantage of these tools and how they work inside their more familiar environment. So this is another editor. This is another asset, rather. And what's different about this one is we can actually apply it to something else. So what we're going to do is, instead of having that rock floating in space, we're going to select these 3 pieces of geometry, and they're going to become the rocks. And the rocks sort of go and encompass that. So even though it's positioned over here, it's actually looking at that geometry. So you can have a digital asset interact with geometry that you have in Unreal and have them connect in this kind of way. So that's pretty exciting. So now let's just test the level out, go around, we can run around, and there the assets are. So essentially, once you press play or you turn you build your game, then these assets become baked into the environment, and they work there. That's why when the assets are made, they have to be made using techniques that are game friendly. And later, when we learn how to make our own asset, we're going to talk a little bit about some of the things there, things like instancing and maybe some poly reduction, things to make sure that it's game friendly. Also, you can include things like collision geometry and other effects. Now here we're going to take that tree and we're going to bake it. So one of the things is, not only will the assets get baked when you run the game, but you have the ability to say, you know what, I don't need it procedural the whole time. So what I'm going to do is I'm going to bake it. So you'll have your live procedural one that we're controlling here, and then you have the baked one, which is a little more static. Now what we're going to do here is we're going to bring in a placement tool. So this is another digital asset that comes with the starter kit. And it just says, you know what, I want to place a bunch of objects along a line. So I'm just going to go and fix that line. We're going to move that line over here. And let's move that last corner over here. Now right now, you've just got a bunch of little boxes representing this. So what you're going to do is, let's just change the spacing on this. Let's go more like 3 meters. They're so a little tight. Maybe let's go 5 meters. Great. Now, once we have that, what we have is the instance object. So there's that little box that I was talking about. You can actually replace that with other content. So we can go here to the Houdini engine, go to the bake section, and we can take that baked tree and put it on. And now we have a whole line of trees being manipulated. And along the way, they're being rotated and so on. You can actually go, we probably don't need the original one, just delete the original one. So now we have the baked trees. We have the one live procedural tree, and then we have a line of trees here that you can manipulate like this. You can also control other things like their rotation and different aspects of them along the way. And that's like, if you really wanted to, you could twist them around at the end. Maybe do a full twist, just if it was a different kind of asset, you might want to do that. It doesn't really work for this case, but you've got other kinds of controls. So you can put a bunch of elements along a line, telephone poles or pylons or whatever, and you'll be able to control them using this asset, this placement asset that comes with the starter kit. So you've seen we've got a nice variety of tools within the starter kit. And so anyone working with Unreal Engine is able to use any assets that are available to enhance their game and to help them build their 3D environment. And there we go. So the other aspect of this is, how are these assets created? Where do they come from? How do they exist? So we can take a look at that by building a simple asset. We're going to build this tombstone in Houdini, and we're going to go through a lot of different possibilities of features that you can add to your tool to make it work well within the Unreal environment. Then after that, we're going to build a small little graveyard using a nice variety of those grave tombstones that we build using the initial asset. So if you're going to use Houdini, it's good to understand the nature of Houdini and how it supports us in this process of creating digital assets for Unreal. So the key is that when you do something in Houdini, everything you create becomes a node. And these nodes get connected to build networks. Each network defines a recipe, and the recipe can be used over and over again. And networks can be packaged up into digital assets. So what this means is that while you're working, you create a bunch of nodes and into this network. Is you can package them up into a single node that gets stored on disk in a file called an HDA file. You then build a high-level interface for that by taking parameters from inside the network and promoting them to the top level of that main asset. Then you can take that back into Houdini, and it acts like any other tool. The interface is available, and you're able to manipulate it like any other tool in Houdini. As a matter of fact, a lot of the tools that come with Houdini are actually digital assets put together by the developers. Now, what if you want to go and do the same thing and take one of these procedural digital assets and put them into Unreal? Well, theoretically, that doesn't work by default because Unreal doesn't recognize that kind of asset. So what you do is you use the Houdini Engine plugin. And that plugin allows you to import HDA files or digital asset files. And then the Unreal Engine will present you with the interface, which we just saw with some of those starter kit assets that we created. We brought them in, we imported them, we were able to manipulate them and control their interface. So this is sort of the ecosystem by which these digital assets work. So here we are in Houdini. We're going to start by just building a box. We're going to take that and change its size to make it a little tall and thin. And this will be the base of our tombstone. Now, we go down, here's what's known as the geometry level in Houdini. We're able to select these edges, and we're going to polybubble them. And you'll notice that as we do this, the two actions we've taken so far, the creation of the box and the polybubble, create nodes. And they're there in that network there. And each of those nodes has parameters, and we're manipulating those parameters. And this sort of comes back to what we talked about earlier about this node network that we're going to be able to package up into an asset. So we also put an expression in here to make sure that the tomb is always sitting on the top of the ground. So no matter how tall we make it or any changes we make, it'll always sit on the ground. Now, the next thing we want to do is we want to select these two nodes and package them up. So we're going to make a digital asset out of this. We give it a name, tombstone. We put it into the proper folder. So accept to put that into our project folder. And it thinks about it a second, and then it's going to bring up a type properties window. We won't do anything with that for the moment, but we're going to go and import this asset into Unreal. We're just going to go into the Houdini Engine folder. We can store our assets in here. Import HDA tombstone, and there we go. Now, when we bring that over, if we were to just click on that there, I've got a nice position there. Okay, if we go and look at that, There are no controls on this. All we see is our transformation ability. At the moment, this is acting very much the same as any static asset you might bring in. To make it procedural, we need to promote some ideas, some parameters from the lower level. So we're going to take this box, we're going to bring the size of the box, because the size of the tombstone is probably a good starting point. And then we're going to bring in the bevel, the amount of bevel that we have there. And we're actually going to change the name of this to corner bevel, just so it's a little more understandable to the artists when they work with this asset. So once we've got that, we see that there's an interface there in Houdini, and we can rebuild this asset here, and that same interface becomes available in the Unreal Engine. If we want to change that to 1.2, that can go up. We want to play with the corner bevel to get a little more like this, and there we go. So very nice, simple control over what's going on. And every time we manipulate the parameters here in Unreal, under the hood, Houdini is processing and giving the result back. So that's a very simple thing. So let's build up this asset, add some complexity to it so we can really get a feel for how far this sort of proceduralism can go in this case. So we're going in and we're fusing the points that we had before. We're now going to add what's called a group create. We want to be able to create a group that's just the front face of this. So we use the normals in the direction of -1, 0, 0 to specifically find that front face. That means it doesn't matter what's going on with this asset. We'll always just find that front face. Now once we have that, when we go to poly extrude, we can go and say use the front group, that one face, and only poly extrude that particular element. So this is how within a procedural network we start to get control, because we narrow things down to what we need. We only need things coming from the front, and then we'll poly extrude that. Now when we poly extruded it, we created a second group, and you can see it here. So we can create a thing called extrude front, and then in this second group here, or poly extrude, we can use that again, another group, so that that's the only thing that we poly extrude. So you can build these relationships within the network to get what you want. Now it's looking like something strange is going on there. The fuse earlier isn't quite doing what it was meant to do, so we're going to go back to that and just maybe tighten that a little bit. 0.01. Yes, there we go. That extrudes nicely. So we have an extrusion and we have an inset. And these are all things that we could promote to the top level of the asset. We're not going to right now, but anything we have in here could be promoted up. And that's part of what's nice about building these assets is you decide what kind of control you want the artist to have. Do you want them to control the size? Yes. Do you want them to control the amount of bevel? Maybe not. Maybe that's something you want to do yourself and you want to just leave that built into the asset. So we're now going to add a second box in. This will be sort of the base of the tomb. And we're going to put that into down there. Now, so we've got the main part of the tomb going above the ground and this part going below. We're now going to merge the geometry and then we'll offset them just a little bit so that the base is popping up from the ground. But we're allowing a lot of the base to go under the ground because we don't know what the landscape's going to be like and where the position exactly is going to be of the tomb when we do a graveyard later. So this just gives us a little bit of something to work with. Now let's save that. What we've done so far, and let's rebuild the asset. And it's only showing the base. Now, why is it only showing the base? Well, it turns out that we have our display flag on the wrong node. We have it on that one over there. This is a common mistake while working with assets. We need that to be on the end. But there is a second solution that's important in Houdini, and that is the creation of something called an output node. So what this will do is once you've got an output node, that will always be the output no matter where your display flag is. So my display flag is on the box. It doesn't matter because when I save this, is the output node will give us the proper geometry at the end. So if you're building an asset, it's always good to use an output node to make sure that it doesn't matter where your display flag is. So there we go. That brings us everything we've got so far. The next thing we want to do is just add some more detail into this. Make this a little softer. Right now it's looking a little hard-edged, especially if we're supposed to be an old weathered tomb. So we're going to add a feature in here called attribute noise. Attributes are a big part of how Houdini does things, and we're going to put in a p-scale with an amplitude of 2.2. Now this isn't scaling anything at the moment, but when we go to polybevel here, we can actually use that scaling to help us. And what you'll see is instead of getting a nice straight bevel, you're getting, now we're not seeing the bevel right now because we've got the display flag on the wrong thing, but we'll fix that in a second. So put the display flag on polybevel, and you'll see instead of being a nice even polybevel, it's a little random. Now part of making this look better will be just, let's go in and maybe make a polygon mesh so we got a little more detail. Now when we first do that, it does everything. It polybevels every edge. But you can actually go in and there's an option for getting rid of the flat edges, so we're only doing the corners. Again, this is nice about Houdini. There's these procedural options that just analyze things and get you what you want. So we're going to take that same noise and we're going to add that to the tomb itself. And we copied and pasted what we had before, so we didn't have to do it again. The only thing is these are not the appropriate values for the tomb, so we're going to want to make some changes there. So we're going to change that to maybe 0.012, so it's a little bit less of a polybevel. Change that normal angle so that it flows properly through there. It doesn't do some of those curvy pieces. And let's turn off the display. So that's what it looks like right now. There's maybe a little more detail in there than we would want. So you can go back. And again, this is what's nice about the procedural networks of Houdini. You can go and change that, change the amplitude, and you can change the number of divisions to 1. And there you go. So now you've got your that set up. It's a little softer, a little more round. And if we save that asset, we can go back to Unreal and just see what that feels like there. And there we go. It's a little softer, and that's working a little better for us. And we just change that to make that a little more round. Now, the next thing we want to do is we want to add a material. So we're going to take one of these starter content, some poured concrete, and put that on there. And actually, I don't think that's the right place. The right place to put it would be, if you're looking at the tombstone here, there's a place for a material there. So let's just put that in there. Now, once we have that, we should see a material, but we don't. And the reason is we don't have UVs. So we can continue to further enhance this asset by adding UVs right here into the network method for creating them. So we're going to add a normal just to make sure the normals are good on this particular asset. Then we're going to do an auto seam. And so there's the UVs. There's nothing right now, but we've created some seams on the geometry. And those seams will allow us to break up the geometry. Now, it's not using the seams right now. The seams generated a group called seams, and we just got to select that. There we go. That breaks that down a little bit more. And then we can redistribute the parts using a UV layout node. And we'll just change that to by island position, and we get a nice UV distribution there. And we're going to go save the asset. And we can go to Unreal, and when we rebuild the asset now, you'll see that the material looks proper because it's taking advantage of the UVs that were part of that texture. So everything you need to do within a procedural asset, set up your UVs, things that are necessary for your game art to work inside the game editor, those can be built here into the asset. And they are procedural. So as this tomb, if you change the parameters and it gets bigger or changes shape or whatever, those things will update. So we're going to add another feature into this, and this is where we can show how the tool can can offer you different options. So we're going to put a plane in and we're going to cut the tomb, make it cracked. Assume it's an old graveyard. Some of these pieces are old. And so this grid, we're going to take that and we're going to do something called match size, where we actually put it right in the middle of that object. So they're connected in that way. Then we're going to put a mountain node on, and that mountain node is going to just agitate that a little bit. And then we're going to take a bunch of these nodes, just lower them down. We're going to add a Boolean down, and that will allow us to shatter the piece of geometry. So we bring the mountain into the second, the poly extrude into the first, and we're going to change this to shatter, which just basically uses the one surface to slice it. And then we can feed that back in the network. But before we do, we're going to get a group out of this, and the group will be all the pieces above the line. Now we're going to put a switch node down. So instead of just accepting this option, we're actually going to have it as as one way of working. So switch nodes are a way of creating different flows of data that you can work with inside Houdini, and then promoting those up. So if you go to the switch node, you see we can either have it cracked or not cracked. And actually, we're going to just change that to 15. It does not need to be quite as strong an angle there. So you've got a couple options here. You can either have it cracked or not have it cracked. And those options can be made available to here. And you can also control whether you make it available in the user interface. So we're going to put in the select input, and we're going to turn this into, is it cracked? And you can make that into a type. We're going to make that into a toggle. I think that's way down at the bottom. Oh wait, no, before we do that, no, that's what we want. We want to go here, and we want to make that a toggle. And press accept. And so once we've accepted that, we can rebuild this, and inside you'll see that it looks a little different. You can have it cracked or uncracked. Cracked or uncracked. So that option is there. Now it turned out to be cracked by default, and the reason for that is the defaults. You can go to here, and the default is 1, which is on. We could make the default 0 and accept that. It won't change it, I think, here because you've already pressed the button. But if you were to totally start from scratch, then it would be uncracked by default. And then you'd have to turn it on if you wanted to have the crack. So there you go. We've made that available as an option. Now, back in Houdini, if we want to, we can add more parameters from this to enhance it further. Let's add a separator in. You can build the UI with little elements like separators and folders. And what we're going to do here is we're going to bring in the rotation of the crack. So just in case you want to control what the crack angle is. And the other thing is using the mountain stop, we can change the sort of the noise or the agitation by bringing in the height from here, and that will be another parameter. So like I said, along the way, anything you think that you might want to give control to the artist when they're working with the asset, you can promote that and have that work. Now, we'll tinker with those features that we've added later. In the meantime, what we want to do is we want to have a bunch of different options for how this particular tombstone looks. We want to have it cracked. We've already figured that out. But if it's cracked, maybe we want to remove some pieces or move the top piece away, or maybe keep it. So we're going to create a menu option of different possibilities. And to do that, we need to create another switch node, and that switch node needs to find the right pieces. So we're going to start with a split node that takes the top of the tomb away. And the split node puts the bottom of the tomb on one side and the top of the tomb on the other. So if we, as you can see with the match size, is the top of the tomb is going off on the right and the bottom's on the left. So we're going to go and we're going to rotate that, let's say 90 degrees. Actually not there, 90 degrees in Z. We're going to position that over here, rotate it a little bit, and push it back. Actually, it looks like it's upside down. Maybe we need to go negative 90. And then we'll just rotate it like this and have it back there. So it as if it fell off. Now we're going to go in and put another match size down. And in this case, we don't want to center it. Instead, what we want to do is leave X and Z, and we just want this to be minimum, so it places it on the ground. Now, it just occurred to me that this is all happening above, before we move the base, before that transforming. We probably don't want that. So we can wiggle this out of the network. This is some of the flexibility of working with Houdini, and say we don't want to do that there. We want to do that down here. So we're going to split it there. We're going to have the same piece go off, which it's working. It's hitting the ground properly. And then we're going to merge that back in. So there's a couple different ways that we're going to want to merge it in. One is we're going to merge it after the crack. Well, there's a switch node, which is where we're going to have our choices. So we're going to start with one merge, where we're going to merge the original bottom shape and the moved top shape, and that gives us our option there. Now the other thing we can do is so that's the second option. So one is cracked and one is there. We'd like a third option, which is to have it cracked, but not having fallen at all. So we see the crack, but it hasn't either broken off or disappeared. So in that case, there's the one where they're all working together. Now we can change the order here. So there's our three options. So it's either cracked but available, cracked and gone, or cracked and on the ground. And we want to make those available up to the top level. So just like any other parameter, we need to promote this, but we're going to turn this specifically into a menu. And the way we do that is we edit our properties, and we bring another separator over, and we're going to take this switch node and we're going to put it there, and we're going to call this just variants, so we can create different variants of the thing. We're going to use a menu, and 0 is going to, we can give names to this. So 0 is just a straight, everything, it's cracked, but it's straight, it's aligned. Number 1 is broken and gone, and number 2 is broken with the piece on the ground. And there we go. Now we can also take other things here. Now to fully make this procedural, one of the things I'd like to do is we didn't create a relationship between the two boxes originally, and I want to make sure we correct that. So if we were to make this box bigger, the base box would not go with it. So what we're doing is we're going to paste a relative reference. So the size in X of the tomb above plus 0.15 will give us the box below. So they're sized in relationship to each other. Now, it doesn't change anything right now, but if we were to change the width or the depth of the tombstone, we want this base to have the same. So we're going to paste relative reference and plus 0.1. So sometimes you've got to build those relationships into an asset to make it fully procedural, and that's something we forgot to do earlier on. So we build that, and there we go. So now we're going to save the tombstone, and you'll see that we've got our menu here with our variants, the cracked or uncracked option, and this gives us a lot of control over what this asset does. We can go in, rebuild that, and there's that menu. There's the cracked and uncracked, and there's the different. There's the broken with the piece. There's just the broken with no piece. And there's the straight one. So it's got the crack, but it's still aligned. It hasn't fallen off yet. So there we have this asset, and let's just talk a little bit about what we did there. So we just built an asset. So we worked on it on our computer where we had both Unreal and Houdini. We were able to save that to disk and then re-ingest that in and test it out. So we create and test an asset. Now, once we have an asset and we feel that it's ready for our game, we can distribute that to other people using Unreal Engine. And they're using the Unreal Engine plugin. And they do not have the ability to run the interactive version of Houdini. They can only run the Houdini engine under the hood. And they can consume these assets that we've created. And this is a big part of the Houdini pipeline. So you've got the tool builders and then the people who consume those tools and use them in their work. And if at any point they say, well, the tool isn't quite doing what I want, they can go back to the tool builder who can update that asset. And when a change is made to the digital asset, those changes will be distributed to everyone who's working with them on the different levels. And they'll have those new features or benefits that have been added to that tool. So the next thing we're going to do is build a little graveyard, and we're going to do that using instancing. So we're going to build an instancing asset similar to the placement tool that we did earlier, but instead of along a curve, we're going to do an area. So we're going to draw a curve to represent an area, and we're going to draw it, make sure you draw it clockwise. Close that and press enter to finish. Now once we have that, we're going to go back to the tombstone. We're just going to borrow the first two nodes just as a temporary representation of what we want to copy. Now when these get pasted over, the because they had channel references in them up to the digital asset, they sort of broke a little bit. So we just need to replace that with the original values, and the same with the poly bevel. That distance was promoted up to the top level. We just need to change that channel reference to just a straight number. So once we have that, we're going to copy to points. So we're going to copy the box to the points, and we're going to use a particular feature called pack an instance. This is the most efficient way and makes it available as instancing in Unreal. And we want more than just 4 of them. So let's add in a scatter and align node here, and this will allow us to do a number of things, get good coverage there, and then we can do things like have different sizes, so we can just have some variety in the shape and size of the tombstones. So instead of us having to do that by modeling different tombstones, the tool will help that with us. We can then get some, if it's an older one, they're sort of tilted off a little bit, and we can have some rotation, negative 10 to 10, and that can be all built into the asset and can be controllable. So once we've got this, these features, we're going to just make them into a digital asset, just like we've done before. And we're going to call this graveyard, and we'll just put that into our project folder and accept. Now once we have this, again, we want to promote some parameters. Just like we did before. So we're going to get the scatter and align is where a lot of the action's happening. So we can go and promote the various parameters from here. So we're going to bring the coverage over, maybe add a separator. Then we can go focus on scale. And then put the separator back. And then maybe go down to the orientation and grab those things there. So that gives us some good flexibility when working with this in the Unreal Engine. Now the other thing we want to do is we want that original curve to be something that we can manipulate. So we're going to go in and promote that curve to an editable node and press accept. And we'll see what that means in a second when we go to Unreal. In the meantime, you can see here in Houdini, there's all the interface. Now we're back in Unreal. So we're going to take the original tombstone and just push that a little bit to the back. And just let's get a better look at the overall area, because this graveyard asset is going to be a little bit bigger. We're going to import this in. We go and get it and import that in. Now we bring that over, and there we go. So we got this generic tombstone being put around with some varieties, different angles, and so on. And we can take the points of the curve. So we promoted that curve up, and that allows us to take these corners and move them. We can also press the Alt key to add points into the curve and further enhance it that way. So that's a nice feature for creating some interactivity for your game artists or level designers, the ability to work with these curves as an input device. So now we're going to go back to the original tomb, and we're going to bake out a version of it. So you'll see that there's a baked out version that's got the crack, and then we can find it in there. Now if we go to the graveyard, we can go down to, there's an area, well, there's the parameters, so we can play around with various parameters. Maybe we change that to 1.5. So we've got all that procedural ability. But there's the instancer. So we're going to go in and we're going to drag that tomb there. And now we've got the tomb that we've designed earlier now being used in the graveyard. Now what's fun is we can also make more of them. So if we want to play around with the bevel to get a different look, then we can bake that. If we want to create a version that is cracked or broken, we can bake that. And if we wanted to create a version that's baked with the piece, so all those different versions, we're going to make those as some baked versions. And there you can see in the bottom corner that we're piling up some options there. So once we have those, we can go back to the graveyard and we can add different instancing actors. So we can say, you know what, I want a few of them to be like that, and it randomly sort of places the two different kinds that we have there. We can add another one and add some in that have missing pieces, and we can do it again and add there. So we can add, if this is a larger graveyard, we can have a nice bit of variety in the different kinds of assets that are being instanced. And let's take it further. Let's create one that's just normal straight with a corner. There we go, and that'll add some nice variety too. So we set the bevel at 0, and that's creates some more of a straight one. So we add another one, and there we go. So this tool that we built is doing some nice instancing of these assets within the environment, and we can actually play that and just walk around and get a feel for it. And we can collide with them and run around them, and there they go. So we've been able to populate this scene, design this level using a whole series of procedural assets, some of them from the starter kit and some of them that we built ourselves. And one of the fun things with the instancing is you can actually take other things, like for instance this steam here, and if we add in here, we can add that in, and now some of the graves are replaced by a little bit of steam to give some mood to it. Now we're going to reduce some of the other ones out just because then we get more steam. There we go. And now we press pause and we can press play, and there we go. And now we've got everything all set up. A little bit moodier look for our graveyard. Okay, so now you've learned how to use assets, how to make your own asset, but let's talk a little bit about how to get it prepared on your computer. How do you install and license this thing for use in your work? So the first thing you do is log into the Side Effects website. You would download the Houdini software. Now you are downloading all of Houdini, but you might not be using Houdini. It depends on what your license is. But Houdini will always be there under the hood when you're using Houdini Engine. When you install Houdini, you've got to make sure you click the Houdini Engine for Unreal option to get that plugin. Now, when it gets installed with Houdini. You got to go find that plugin, and there's a directory there that you have to. It's a Houdini Engine directory that has to be moved into this path for Unreal. So it's the Engine Plugins Runtime directory. You find that, put the Unreal Engine in there, and then when you load Unreal, the Houdini Engine will be there. Now, having the plugin isn't enough. You need a license for it. So you can go to the Houdini Get Buy and click on the last tab, the Houdini Engine for Unreal and Unity. And in this case here, you just get a free license. And this will allow you to run the asset, run the starter kit tools and so on, no problem. Now, let's go over what your different options are from a licensing point of view. So if you're a commercial artist, you would be using Houdini Core effects to create your digital assets. Those assets can then be run using the free Houdini engine for Unreal assets if you just want to consume the assets. Or the interactive licenses, you can use Core and Effects. So if you're testing the assets or working with them. And the file format, the only file format that's consumed in a commercial setting is .hda. Now we also have an indie version, and it creates a different kind of format called HDA-LC, or limited commercial. And that works with Houdini Indie. There's a free Houdini Engine Indie you can get, and it works in the two of those. Now, when you're working with Indie, you can open HDA-LCs or HDAs run that were created in a commercial, but you can't go the other way. And that's just a protection system within our ecosystem. And similarly, we have the education or non-commercial version of Houdini, which creates .hdanc. Now, in the case of the Houdini Apprentice, there is no matching version of engine that runs the plugin. So you cannot run the plugins with Apprentice. But if you are working with education licenses, there is an education engine license that does work. So there's a little more flexibility there. So if you're a student using the free Apprentice edition, you can just bring your assets into class and work with them there. Again, just to diagram this out. So we talked earlier about the person who creates and tests the assets. So the licenses needed there are either Houdini Core or Houdini Effects. But if you're consuming assets, you can use the free Houdini engine for Unreal. And so, it doesn't matter how big your team is, they can all have access to the ability to manipulate and work with those assets. So that's a great feature right there. And on the indie side, again, same thing. The difference is that when you're consuming the assets, you can only use up to 3 on a team for indie licenses. So it's assumed to be a smaller ecosystem that you're working with. For reference, many of the things we talked about today, if you go to the SideFX website, sideFX.com/Unreal, there's a page that specifically outlines many of the things we've talked about here, shows you where the starter kit is, talks about other connections we have to the Unreal Engine, things like the Niagara plugin for particles and the live link for doing character rigging type stuff. And so yeah, be sure to go there if you want to get started. Well, thank you very much. I hope you have enjoyed this presentation and got a good introduction into the world of Houdini and Houdini Digital Assets. The next presentation is going to take this a little further. It's going to stay with the cemetery theme, but Simon Verstraete is going to talk about building game-friendly assets, and he's going to build a larger cemetery using landscape, elements, trees, grass, different kinds of grave elements, tombs, and how to get them all working together to create a bigger experience for developing a game. Again, thank you very much and have a great day.
Hello, welcome everyone. And this is the next part in the workshop. So here we are building the cemetery. So in this talk, I want to talk about how I built the cemetery, but also how did I bring it into Unreal. Because part of what we generate, we want to also open this into Unreal Engine. Or you could also use these approaches to open this in Unity as well. If you have seen the previous workshop, you will also get some information about how things are working in Houdini, some procedural approaches, and some basic understanding. So again, in this video, I want to talk mainly about the cemetery scene and bringing this in the game engine. So the cemetery scene itself, here are some shots from the game engine. So you want to have a few procedural assets and procedural placements of props by a Houdini tool. Have this whole area automatically being filled and calculated based on rules we are making inside of Houdini. So an artist could, for example, draw the area of the cemetery, and then the Houdini tool will then calculate whatever is needed for that. So in Houdini itself, we basically then have this as final result. So we have a terrain and we will have points on that terrain, and each point will contain data on what model to use, which is called instancing. So each point or the point cloud has an instance attribute. So we also then have a unique parameter interface where we can play around with values to generate different results. So in a moment, I will actually then jump into Houdini and actually go into the tool a bit more, but here's just like an overview of that. Some other things we built for this tool was a cemetery, was a procedural tombstone generator, which is a small tool to generate a variety of tombstones. As you can see here, I can have a basic one. I can, for example, add some basic candles, or I could make it destructible by breaking up some chunks here and there, and things like that. Another procedural tool was here for the tomb itself. So we can have basic parameters to change the scale or the size. So we can make it smaller, make it wider. We can change the roof style. We can change the door there. So we can just play around with a lot of different parameters to make sure it works in our scene or generate variations. Also, we have trees, which are also procedural in Houdini. And specifically here, we use the lab tree toolset. So if you have been using side effects labs, you have the ability to have the trees for that. And this is sort of like my final, I would say, assets I have used to make the final scene. So again, all assets have a procedural touch or background. So again, the tombstones procedurally generated, tomb, the tree, the grass, the stone fence, they all have a procedural background or are made in Houdini. So for example, like the fence, it's not like a full procedural tool. It's just like a procedural approach, but not like a full tool like the tombstones, for example. Like the tombstones were very useful to have its own tool since I want a lot of variation there. So the topics I want to talk about in this workshop is giving you some overview and some detail on how the scene is built, on how to give you some context on how it's approached, and also when I take it into Unreal, you also know a bit what's going on. Now, secondly is then actually preparing for Houdini Engine. So I want to prepare some data or maybe delete certain data so we have a clean result as output for Houdini Engine to use in Unreal and Unity. So the scene itself. So I'm gonna jump over into Houdini for that later, but the main things I want to focus around is building the terrain, having certain inputs, having also talking about asset placement. So these sort of are three main topics that are quite important here to make the scene. So again, we need the terrain as ground to start on. We want to have user inputs to make sure we have artists controlling where certain positions are. And then we also have our asset placements, like where do I place a tree, where do I place a tombstone, things like that. The next step is we have the Houdini engine. So if you would be very new and did not watch all the workshops, Houdini engine is basically a way to open Houdini files into game engines or even Max and Maya. So we have a Houdini user making a tool, they can share that tool, and they can then use that with other artists making something in Unreal or Unity, and they don't necessarily have to know Houdini. They could be non-Houdini artists, and they can just open and play around with these tools by the plugin, the Houdini engine. So if I make a procedural tree, they can open the procedural tree and play around with the parameters I made for them. So to prepare our data then with Houdini engine, there are a few areas where I want to talk about. So preparing the terrain, so how do we actually get that terrain in the game engine? We then also want to talk about on instancing. We can also automatically assign materials and also talk about collisions. There are also different types of data you could prepare and handle, but most of the time you will mainly talk about instancing, terrains, and materials. Those are like the three things you will often need to prepare data for to work nicely in Houdini engine. The docs will tell you even more about what you could do with these plugins, so I can heavily recommend you searching the Houdini for Unreal documentation. So also each game engine has its own features sometimes. Like sometimes there are features from Unreal that you could use, but sometimes there are also features from Unity that you could specifically call with a group or using instances, attributes, things like that. So definitely worth checking out the documentation on what is possible with certain packages like Unreal and Unity. So with that said, we are done with this small presentation, and I want to jump into Houdini and actually talk about the network and what's going on. So here we are in Houdini and we have our scene. So I have one main tool here again where I calculate the terrain and all the points where my model should be. Like I mentioned, I have built other tools like the tombstone maker here, where you generate tombstones, and I can have different types of tombstones, like you could see here. I could generate them. So in previous workshop, there was some information about that as well. But yeah, you can get these files as well and look into more detail. Also here, like a small tomb maker where we can play around with this as well. And then here again, like if you're interested in making procedural trees, check out the lab tree tool set. So if you just type in trees, you should be able to see the lab tree tools. So these are all available for you for free to try out and use. We also have tutorials covering these, so check out the tutorials as well. So let's go into here our main tool and talk a bit about that first. So here we have our tool, and we can open here our parameter menu, and we can see that we have a lot of different parameters that we created. So again, this workshop is also meant for someone who's already a bit familiar with Houdini and knows how to make custom tools and parameters like you see here. So I have different parameters, like if I want to change the seed, so I could play around here with the seed, and then I will take a sec and calculate a new version. So now we have a new version of that. So I can change it back to normal. And now we have that version. So again, I build a lot of different variety of properties and sliders. You can build more if you want to, like you have the option to build more. So I have specific options for cemetery, like how many tombstones I want. I have options for the tree, how much trees we should have, and then also instancing, which I will talk about later when we bring this into Unreal. So let's jump into the tool and give you some context on how this works. So here, if you would open the tool, I've made a small color coding. So the green one is the terrain. So this will be all about calculating the terrain and integrating the shapes into the terrain. Then here I have this orange box, which is basically the user inputs. So like if I draw a curve, my terrain has to adjust to that curve. So these are like inputs for like curves and so on. And then here we have placeholder models. These are just models for previewing what's going on here. And then furthermore, I also have like the blue area here, which is then for preparing the data for Unreal or Unity. So let's start at the beginning and talk a bit about how I created the terrain. So here we have this block, and this is the base terrain shapes. So overall, this is quite simple in setup. It's not super complex here. So we have our basic height field. We're going to make sure we have a good size. So in this case, I took 500 units. And then with the scaling difference between Unreal and Houdini, which is always 100 units difference, this will then be quite larger terrain already. So with that terrain, I'm going to make a noise on that. And we're going to have a noise like this and a one that's a bit more rougher in shape. And we're going to blend that together. So we're going to have like the sort of like the mountains of the rough noise and then the flat surfaces from the other noise. So we have this result. Then next up, what I like to do is then the slumping. So here, if I look at that, this is basically smoothing the area. So if I would remove the slump, it will basically sort of simulate a dirt on top of this. So it sort of feels like it's like a dirt layer, and that we can also spawn grass on that as well. This glimpse is also based on a mask, so you need a mask for that. And then next step is also setting the resolution. And if I dive into that, I just made a switch. And important here is that we make resolutions that are specifically game friendly. So each terrain system from Unreal or Unity has specific resolutions for terrain data. So in this case, it's 505 instead of the 512. So you're going to have to look up what's the best terrain resolution. Houdini Engine will sometimes automatically convert that to what's the closest, but it's always a good idea to set it properly from the beginning. Now, next up here in the network is the fencing around the cemetery. So here I'm going to project a shape to define my cemetery area. So here the shape is actually from my input. So here I have an input, which is this curve, as you could see. And we're going to basically also move up the curve 200 units. So I'm going to make sure it's actually flying above my terrain. And the reason why it needs to be flying is because I'm going to project this with the ray. So in the ray node, we can project this based on a vector direction, which is -1. So basically look down from that original curve. So here's my curve, and we're going to say look down until you hit the terrain. So that's basically projecting on the terrain. And I'm going to use then a polywire, or you can also use a sweep to then give it some geometry, and then we project that into the terrain. So of course, the more quality you have on your terrain, the more detail you will see. So in this case, I don't have that much detail going on. So you can see it's not perfectly. So you're gonna have to choose what you want to see, like more quality or just something. Of course, the lower your quality, the faster it will work. So next up, let's move on to creating the cemetery area. This is basically then a mask, the red mask, to sort of know where cemetery areas are. And in this case, I have two areas. So I have here and here a cemetery area. And I use a very similar approach by basically using this curve that we projected and closing it. So in the close is basically then a add node, which is set to closed. So if I then take this, we are opening and closing those shapes. Then next up is then using again some projection, but instead of geometry projection, we're going to use mask by object. So we have a mask, and I'm going to add some noise in there so it's not consistent. And also important here is I'm going to save the mask to a new layer called cemetery area. And that is very important to know, is that we can save out this information to be later be called back again. So later I will use this back, as you will see. Then next up is the walking area. So here I have this walking path. And again, this comes from a curve. So the same process over again. So I basically draw a curve and I put it up over and I put it high up in the terrain. Then again, I'm going to use here projection of the ray. Then I'm going to resample this. Then I'm going to use a sweep with a noise value in the p-scaling. So we have this randomized, as you can see, we will have this randomized shape here. So it's not super consistent. Then we're going to project this in the terrain. So as you can see here, it's super subtle. So we have that shape projected. And I'm also going to make a mask from this. So we can again save this into another layer, which is called path area. So if I would go here to information, I can now see that I have an extra layer called cemetery area and path area. So I can use this to later define, for example, don't spawn trees on the path, because I don't want that and I want to walk around on the path. Now, next up here is then placing the tombs. So here, again, the final result is a mask. But how did I do that? Is by, again, using inputs from the user. So the user would place boxes in the world like this. And then we're going to use this and extract the bottom area. So here, I'm extracting the bottom primitive. I'm going to make sure it's a bit bigger. So I'm going to use a poly extrude with the inset value. So it's a bit bigger in shape. And I'm going to just use the projection here. So we're going to project this in the terrain. And also we're going to project this with the mask option here. So we have the area where this house or tomb will be. So here I'm also using the expanding mode. So this is what you get out of the box. So we are actually also taking that sloped part as well. And I also want to blur that. As you can see, we want to blur this a bit better in the terrain because this doesn't look that nice. So we're just gonna make sure it's like integrated better. So our final result will be that our house will be placed on top of this. So we have that information ready and nicely integrated with the terrain. Then again, same process as before. I'm gonna save the mask in a new layer called tomb areas. These are all the areas where I have a tomb. So again, I can know don't spam any trees or rocks in that area because I have a tomb there. Now we're gonna place the tombstones. So again, we will do a projection of that. So we will project those in the terrain. So these small bumps. So the reason why I do these small bumps is they actually feel like the dirt is going a bit upwards when we place a model. And I've created a small network for this. So let's look at that network. And we're going to mainly look at this one over here. So this is where I actually calculated tomb stones. So here at the beginning, I'm going to call my cemetery area. So here I'm using the height. I'm again using the copy layer, but I'm saying like, hey, call the cemetery area and save it into my current mask. So if I would not do this, this is my current mask. So I would like to see my cemetery area as current mask. Then I want to combine this with, for example, the paths and the tombs area. So I cannot place any tombstones inside of the path because I want to walk there. And also when we have a tomb here, don't place any tombstones there. So the next step is then scattering based on the masks. So we can use the height field scatter node. So we can use this based on the masks. And when we scatter around some points, so these are quite random, we can also then fuse them with based on a grid. So here, if I make this a bit bigger, you can see that we are snapping to the grid here. So they are specifically now spaced out. So they are a bit perfect now. So again, cemeteries are often in a certain structure, in a certain layout. So to quickly get that, I just use a fuse by grid. Now I'm going to use this, move this upwards, and I'm going to use the same technique. I'm going to use the same technique as I did with the curves. So I'm going to move them up, and I'm going to project them back onto the terrain to make sure they lie nicely on top of the terrain. So since I did the fuse on grid, I'm not sure anymore if they are nicely on the terrain. So, and we're also going to make sure if there are any overlapping points, because that could happen, fuse them back together. And then here is an interesting process for rotating them. So here, if I look at the results, you can see that the rotation is based on that color you see here. So I basically group or cluster certain points together and give each group or cluster a specific rotation. So you could see that these orange ones are rotated in that direction. But if I look into another group, they are rotated, for example, in this direction. So each group has a random direction. So it feels like it has some sort of structure, but also some randomness in there. So the first thing I did is using the cluster node itself. So the cluster node itself here, if I view my labels, you can see that we have colors for each of them. So each area is now a cluster. So the cluster node is quite useful for creating these. So you can see that here we have these groups or clusters of points. So now I do a loop and I just using the for each by point. So I can just use that one. And we're going to make sure here that we're going to use the attribute for looping value. So here we're going to fill in cluster. So that's important to fill in here. So you will see that I will also do it here. So I'm going to import cluster. So we're going to loop over each cluster and we're going to give it an orient value. So the orient value will control the rotation of an object. So in this case, I'm also storing this in the detail mode. So, and I'm gonna then promote it back again to points. So the reason for that is that we have the same value on all points. If I, for example, would directly now use points here and make this in the sprite sheet, we will see here that we will all have random values. And I want to have one consistent value for all the cluster. So I'm going to just use detail, and in detail here, we then have one specific value. And if we promote that to the points back again, we can see that we have just one consistent value. I mean, there are some other ways you could do this, but simply promoting that will work. So that's finished. So I have a random rotation for each cluster. And I've also added a small jitter. So the jitter will basically do a position offset. So if I would increase this, you can see that we are just jittering with the position. And I'm going to keep this quite subtle. And this is even exposed as a value. So I can get some more variation and step away from the perfect grid structure I have. So this is basically then my result when I would copy my models on that. So this is my output. So again, I'm outputting only points here. So this is my output, just a group of points, which then will later be used, like you see here, to copy a model on. Then I've also have a special system here for adding trees, because I already was thinking like I want to also add specific trees. And in this case, I took a small note here to actually add trees specifically around in the cemetery area. So here, if I look at where I have my mask available, this is then the area where I could scatter around this tree. And what I'm also doing here, so I have scattered around a couple of points, I'm also using the points that I had from the tombs to double check if there is not overlapping with my trees. So here I'm just copying a sphere on the points, and I'm using a group by bounds to check if my trees and my tombstones are overlapping. So I know that if there would be overlapping, that might be problematic and models could glitch in each other. So I could just delete that. So that's basically my output. So I have two outputs, the tombstones and the trees inside of the tomb area, inside of the cemetery area. So that's about the tombstones. Then next step here is the trees. So I already spawned some trees here in the cemetery area, but I also want to spawn here trees overall. So here I made a mask that is basically calculating where flatter areas are. So mask by feature, and I'm inverting this because this is the slope, and if you invert it, we get the flat areas. Then I can use combine with certain masks. So don't place any where there's cemetery area or the path area. So don't place any trees there. I'm going to specifically here like separate the cemetery area, and I sort of like spawned trees uniquely in there as well. So you could have some more control about how many trees I actually want to have in here. Then next up, what is interesting is calculating the flow field. So this is a flow field calculation. This node is pretty interesting. Like you could see, like the masks, like the mask you're getting here is super interesting to look at, and you really see like the flow. And I'm going to use a layering here, and I'm going to subtract that. So this will give me this mask, which is quite interesting. So we will actually see certain flows in there. So I'm subtracting basically this with this, and then we get this. So again, height field scatter, and then we scatter around points based on the mask here. And I can combine this here with the trees from my cemetery here, from my tombstones here. And this is then my result. I'm going to copy a small sphere on this. And this sphere is basically used to lift where we have trees. So we just have like little bumps where we have trees. So where the tree area is growing, like the roots of the tree might actually lift up the ground a bit. So that could be interesting to also integrate there. So you don't have to do this. You can also play around with this sphere. Like if you need more of this, like you could see, like you can boost this a lot, or you could make this more random. So this can be just be an interesting idea to, again, integrate the model with the terrain better. Then also, again, like same as we did before, we're going to have the mask saved out into a layer called tree area. So later I can call this back again. So we're almost done here with the terrain. And the last thing we want to do is setting up here a road simulation. So we're actually doing a simulation from debris and water to make it more natural. So you will see after the calculation is done, like you could see here, if I would turn this on and off, you can see that we have nice details here in that terrain. So that can definitely be interesting if you're looking into that. So this is how the terrain is set up. So further I have a bit more here about terrains, and this is mainly for game engine. So I will talk about that in the next part. So this is basically what's going on with this whole system and how the terrain was made. So now for our actual models, we already have some information about it. So I know here, for example, I have my tombstones data. So if I look here, so if I would, for example, now have my preview scene here. So this is my preview scene, as you can see, with very temporary models. So for example, I already have the tombstone information. So here we calculated the tombstones. So I can just now use a copy to points with a placeholder or template for just Houdini. Then also here have like the fence, the border, which is this one. So again, we already have that information from the array here. So all the way back up here, I have that information. Now, specifically here for this one is, if you take a closer look at when I draw my curve, we can see that the points are not super consistent. So I did a resample. And specifically here, I did a resample on this specific number because that is the size of my fence. So the points are now evenly spaced out. And if I'm going to copy my fence on the point, it's specifically this size or scale it needs to be. So that's good to know. And it's also sometimes interesting to also set this to a subdivision mode to sort of like make the curve a bit smoother. So that's a bit on that. So then we have that result. I can also see here, if I look at the end of my curve, of my fence, that it is open, and I made a separate system here to then place one pillar here. So here I placed the group range node, and I just took the last point here. So here the last point is not selected, as you could see. And then I basically can use this as group. So group one is basically that last point, as you could see. Also, something important that I've not told you here yet is that I use the orient along curve node. And this will basically make sure that our rotations are correctly. So here you have my fence. And if I would not use orient along curve, we basically get this result. So my fence is totally going nowhere. We don't have any direction. But if I use orient along curve, I specifically have this direction where they follow the curve. So that's just good to know. So that's a bit about the system. Also then same again here for the trees. So I have the information from the scatterer here where I have the trees, and then I'm gonna copy a model on that so I know where trees are. So for the next part, I want to bring this in the game engine, so in Unreal Engine in this case. So you can do the same process again for Unity, but it might need to have some different approaches, but overall the steps would be very similar. So here we have our setup, and before I sort of like bring this into Unreal, I also want to talk a bit about Unreal itself. So currently here in Unreal, I have a scene. This is already a scene that has been generated, as you can see. And what we want to check is our plugin installation first. So we're going to make sure that our plugin is installed. So here I have Houdini Engine. So that means I have it installed. And we also need to create a session. So we need to click on this to create or to warm up the tool. Now my tool is warmed up and you can see that this is also now grayed out. So in case it would, for example, not really connect immediately, you can try to create a session here again. So sometimes you might need to click this another time if it might fail to connect. Also here we can go here, of course, to our plugin settings of our scene, of our project, and we can see that we are using Houdini Engine version 2. And this is also specifically tied to a version of Houdini. So this is also quite important that if you would install a different version of or uninstall Houdini's versions, the Houdini plugin is often bind to your Houdini version. So currently I'm using this version as a demo here. So that's quite important that you remember that to make those versions and to update those files again. So we have videos about the installation, but basically what you do is you need to drag and drop a certain folder into the plugins folder of Houdini Engine, and then that should work. So now my tool is basically warmed up, so we have Houdini Engine enabled, and we can basically then drag and drop our tools inside of Unreal. So I already wrapped up this tool into a digital asset. So as you can see here, I already have my digital asset here, so I already made that. And I can just like look up the location where I originally saved this and drag and drop that into Unreal. So that's nothing special there. So for my current scene here, I'm gonna then quickly start removing things. So I already have like baked out results. So I want to just delete all of the things we have. So let's select everything here, and I can probably just delete that. So now I don't have, so I only have here some of the lights and I have some particles. I think I can also delete the particles here for this demo. So I just have an empty scene with some lights now, and I can now just drag and drop my tool. So I can drag and drop it, and it will immediately start calculating. So again, it will do a whole calculation of a variety of things. So it will calculate the terrain, certain positions, the tree locations, things like that. And this is then the final output. So we have our terrain, as you can see, with the trees, the houses, and some other things. So before actually jump into more of this, I want to like break it down a bit and start a bit from scratch. Just let's talk a bit first about bringing in the terrain. So what I'm also going to do here is I'm going to place my tool here in the middle of the world. So I'm going to reset the position. So it's actually in the middle of the world. That's just useful. So you can see that we also have done the same interface as I had inside of Houdini. So now let's jump back into Houdini. And in here, we're going to have our tool. And let's talk a bit about the terrain system. So here, this is my output node that I have. So everything that is connected will be seen as output. So since I only want to show the terrain, let's output the terrain data here. So let's plug that in over here. So now I'm only outputting the terrain. As you can see, I'm not outputting any points or meshes, just the terrain. So what is special here is I have this process going on. So what is this process? This is basically the mask or layering setup for a game engine. So what we had here is previously we had our terrain, and I'm going to just clear out the mask so we have a clear result. And I'm going to start making masks or layers to drive a certain material inside of a game engine. So what I'm going to do is I'm going to start building up a layer. So I'm going to start selecting the dirt areas, and I'm going to mask that again with some other areas here. And this is then what is called layer dirt. What is also special here is I'm using actually also information from that erode node. So here I'm using the debris, but my erode node is not enabled. So maybe I can go quickly switch to that. So I'm going to go here and enable simulation. This might take a sec. So of course, if you do this in the game engine, it will also take a moment to calculate since this is an actual simulation. So now we can see that we have way more interesting masks here. So before it was just like one big area, but now it's actually sort of like details about certain simulations or things falling down, because this is on a sloped area. So we have more interesting detail. So again, we have a mask. I'm going to save this to layer dirt. Now next up, we want to make another layer, and this one is here for the grass. So I'm going to calculate the flow field, and this will automatically also override the mask that we have. So it will just override that. And flow fields are quite interesting, as you can see, like really interesting results, what you get from flow fields. Then we're going to make sure we combine it with some other masks, like you see here. So we are basically calculating the flatter areas here again, and we're going to start combining things together. So again, I would subtract the dirt layer, the water layer, and add some of the tree areas. So this is where I would like to see my grass. So I'm going to call this then grass layer. So we can also see that we also have some nice detailed grass on the side of the rocks here. So it actually blends a bit with the grass on the border with the rocks. So that could be cool. Then next step is then actually calculating here the rock areas, the rock shapes and cliffs. So I'm basically doing a invert. So I'm going to use a remapper, and I'm going to say to the mask, just invert this. So the minimum is 1 and the maximum is 0. So if you would this reverse, this is the normal mask. And if I invert this, you have this mask. So again, we can start subtracting things like the dirt area. And we can again do the same process of saving this into a layer called rocks. So we have 3 main layers: dirt, grass, rocks, and these will then be used in Unreal. So to finish off, I'm going to just clear off the area so we don't see that. I'm also often would visualize this already here in Houdini with a quick shade node. So I'm going to visualize the layer dirt, grass, and rock. So I know in Houdini that my information is correct. So if I would see something weird, that means that I made a mistake in a certain operation there. Now, what is also important now is to actually delete all the other layers I have. So I'm only going to keep the height information, the dirt, grass, and rock information. So if I would look up here the information about all our layers, we can see that we have a lot of different layers. So we have the cemetery, path, tomb, the tree, bedrock, water, the flows, things like that. So we have a lot of different layers. So if you would open this in Unreal, it will import all of that information, but you don't necessarily want to have all of that information. So that might be too much to handle. So now let's view this in Game Engine. So I'm going to go here and save my asset. So in Unreal, we should just click here, recook or rebuild. And then it should update our scene here. So now it's being processed, and I currently don't see anything. So I might made a mistake, or should probably change a few things. Let's also do a recook. Maybe that will help. Okay, so with the full rebuild, it actually helped on getting my terrain. Recook didn't. So with the rebuild, it actually helped getting my terrain, since I made a lot of changes, like I directly outputted the terrain and did not calculate everything else. So that worked. So here we have our terrain done. So we can see that this is the exact same result we have from Houdini. So we can see we have those mountains, we have those little areas where we should have trees and tombs. And let's take a closer look at the actual terrain data. So if I switch here to my landscape mode, we should then have data from the terrain. So if I go here to, I think it's paint mode, we should now see the layer systems here. So I see grass and rocks. So I don't see my dirt, since in this case there is no dirt. And that makes sense because there is something in my tool. Because there is some setting in my tool currently that is not outputting any dirt layers. So you can see that these layers will get converted into the system here. So again, if you won't delete any of that, like I showed you here in Houdini, if you won't be able to delete this, I can show this, you will see all of these layers. So here, save assets. I might also disable here the simulation, since I don't want to wait every 10 seconds to be saved here. So let's also disable the simulation here. So that will just go faster. So now it's almost instantly. So now if I would jump back out to my normal view and I go here and rebuild my terrain again, we should see that the terrain will contain a lot of different data. So we only had 2 data because I filtered it out, but now we should see a lot of different data in the terrain. What you can also see here is that the tool takes a lot of time for calculation. I actually made here a like a fast mode. And the other thing you could do is actually reduce the resolution or the quality of the terrain. So the lower the resolution, the faster it could calculate and bring it into Unreal. So but for now, I'm just going to leave it like that and talk later about it. So if I go now to landscapes, we can see that we have all these different layers. But again, like we have the flow, the water, the breeze, doom areas, and other stuff. Like there is so much data you could import, but I think it's safe to control what you're outputting, since you might not want to have unexpected data everywhere from this. Then let's jump back into Houdini and set up things a bit further. So I'm going to switch it to normal mode again and go into Houdini. So here in Houdini, let's enable here my blast node again. So this is basically again filtering the layers. And next up is automatically assigning a material. So what you saw was, so in Unreal here, you see basically no material. Like it's just like the default checker pattern. So you want to automatically assign a material. So I made a small material here, terrain material, and I want to use that. So we can do this quickly by just saying Unreal material. So this node will add a attribute, which is called Unreal material, and will add then the material. So we're going to have to fill in a path to the location of that material. We're going to have to right click on the material. So I have my terrain material here, and we're going to say copy a reference. So we want to copy the reference where this is in my project. So when we have that reference, we can then paste it into here, and now it has a direct link to that material instance. So if I would now start saving this, it will immediately work. So if I would now start recook my tool, normally it should also now add the material as well. And as you can see, we have automatically the material. So maybe switching to Unlight mode, so you can see that we have the grass and the gray of the rocks going on. You can also see that I automatically spawn grass based on materials. So the grass system is built inside of Unreal here, because it's automatically also based on distance. So you can see that for performance wise, this is a bit easier to implement since it's automatically done by Unreal. And for those of you who are interested in the setup of the material, we're gonna take a quick look at that. So here I have my material, and let's take a look. So the main thing that is important here is this one here. So we have the layer blending modes here. So if you just type in like layer landscape, So we can have this node, and then we just basically add how much layers I want. So in this case, I have 3 layers, so we're gonna have 3 different tabs here. So we're gonna have this. So you will need to give this a specific name, what you set up in Houdini. So in my case, if you remember, it was something which is called grass layer, and then I have dirt layer and rock layer. So basically, as you could see, dirt, grass, rocks. So this is how this works. And then I give this a color. So my dirt is here, this color. So this is basically for my dirt, and I also mixed in some noising, so I get some variation. Then for my grass, I just basically have a simple green color, nothing special. You could also like do something with like this with like some certain noising, so it's like a bit variation. And for my rocks, I just use this gray color. So this is of course super simplified, because in reality, you want to actually make this with real textures and some more parameters to play around with. But this is what it would look like. You could also like copy this for the normal map like I did here, but I ended up not using it since I had some more stylized approaches. So you could also like have 3 normal maps on each layer. So that's also possible. So there are some more tutorials on YouTube explaining more about terrain materials and so on, but this is at its core, it's basically this node controlling the layers of the terrain. So with that set up, we have our base terrain. But next up, let's also talk a bit about this fast mode that I had here. So let's quickly talk about that. So I'm going to enable fast mode, but it's probably not doing anything. If we go into Houdini, I'm going to plug this back into my system here. So this is my terrain. So this is basically the fast mode. So this is a switch node that is switching between these branches. So the fast mode is basically checking the terrain system only until here. So it's not doing these calculations. So it's not calculating tombstones, trees, erosion. It's not calculating all of these things. And the reason for that is because this takes more time to calculate than this. So this is just way faster for visualizations. So again, like this is only for visualization and working faster. So the artist has a sort of like a nice workflow where they don't have to wait 20 seconds for every small update. So this is just a fast mode, which contains the basic information from that. So again, like the layer system is similar. So we're gonna have to again create layers for the rocks, and we're gonna create a layer here for then the grass, and then a layer for the paths and other stuff. So we have that information available. So this is basically then the fast mode. So if I would save this, we would now be using that as well. So one of the reasons why I use the fast mode is, because I'm going to switch to the next thing, is our inputs. So we want to make sure we have inputs from Unreal inside of Houdini. And the reason and the way I do this is by using a object merge node. So if you would type in object merge, this is what I use all the time or often for inputting data from the game engine. So with object merge node, what we're going to do is if we're going to go to our properties, we're going to basically expose the object level here. So I'm going to drag this into my scene, into the parameters, and this is then basically a special menu in Unreal. So in this case, I already made this, so I'm going to delete this back again here. But this is how you would add a object merge node. So as you can see, this is my object. This is my input for the Unreal, for the fencing system. So I input my curve. Then I'm gonna actually do some cleanup. So it is possible that there is certain data on the curve that could conflict with my system. So I'm just gonna clean every single attribute and information on there. Then I'm also going to do a face node, and this is basically a cleanup of the line. This will just clean up points And I'm also going to do a resample to control the positioning of the points. So again, I want to specifically space out the points on this distance for the fence. And then I'm also using a switch node to switch automatically between these things. So if I don't have any inputs, use my hard-coded curve. If I would have an input, like say if I certainly have an input, it will then automatically switch to then this input here. So that's what is going on here. So this process about inputting, as you can see, I'm doing this multiple times. This is then for the paths. So same process, inputting a curve, cleaning up the curve, and then using this. Then also then for the boxes, for the tombs, I'm just only using the object merge, and there is no cleanup here involved since they are basic boxes that I'm going to use, so no need for any cleanup. So this is how I set up inputting. Now let's jump into a drill and show it in action. So here we have our inputs, and as you can see, this is the special menu that I'm talking about. So you can see that they are quite special in setup. So first thing we want to do is I want to actually have also a curve in my scene. So I have a blueprint with a curve. So here we can drag and drop that curve. And as you can see, it's like a basic curve or spline component in Unreal. So if I quickly show the blueprint here, if I go to viewport, you can just add spline and then just add spline here, this one. So this is a very basic spline, and I'm also going to make sure it's actually set to a linear spline. So I just like the linear a bit more since it can be more controlled or quickly controlled. So what we're going to do is let's place it here on the surface, and let's draw a area for my cemetery. So I'm going to grab the point and make a cemetery area like this. So we have this curve, and we're going to now use our input for my fence. So I'm going to switch, instead of curve input, I want to actually use a world input, so something from the world or in my scene. So we're going to switch this to world outliner. You can see there will be some calculation here, and I'm going to make sure I'm going to select the curve, and I'm going to select this one and use as current selection. So it will input the basic curve, as you can see here. And the tool now automatically sees this as an input. As you can see, we have this working. So if the fast mode is enabled and the resolution is not set too high, you should be able to have a quite responsive way of working now. So if I would grab this point and place it over here, it should only like take a sec to calculate. So that's quite fast in working. So again, like a artist level designer could come into this and like design a certain level for this cemetery. So this is how I would then place this tool. So you can see that I'm also here doing like a smoothing of the curve with the resample. So it's like smoothing that out. And then let's also bringing a curve for the path. So I'm going to make a new curve. So I'm going to drag that in here. I'm just going to rotate it like so. And let's say I want to have a path coming from the middle that goes like down here to over there, something like that. So we don't have to be like super accurate. As long as the curve is above the terrain, we should be fine since we are projecting that. Then again, same here, we're going to choose world outliner. So we want to pick something from the world, start selecting, click on my curve, use this as my selection. And now I have the path here. So again, this should be quite interactive. So if I would grab the point, and it should immediately update. So again, we are doing some certain like smoothing of the curve, so it's nicely fit in. So that works fine. Now the last thing that we had here as input was then the tomb area. So we're gonna also, first of all, pick a cube. So we're gonna pick the basic cube. And I'm gonna actually change the scale to, I think it was something like 5. That is a proper scale for this. I'm gonna place it, for example, here. Like here, I would like to have a tomb. So now if I can go here, world outliner, start selecting, use this. And now it should also blend with the terrain. So if I lift this up, the terrain should also lift up as well. So we're gonna make sure wherever your cube is, we sort of have that lift up. So even if I want to specifically have this here, like a bit higher up, it will automatically sort of like blend that with the terrain. So you can see it's sort of like lifted up the terrain here. And this is how you can use inputs. And again, like building a fast mode is very useful here. So that's very important that you might need to think about the artist working with the tool, that they want to actually have something more interactive instead of having to wait longer. So if I would disable the fast mode, you will see that automatically my terrain will now take longer to calculate because it needs to calculate some of the like flow fields and so on. So it will actually take a bit longer. So if I would now grab the point, you can see it already takes a couple seconds more. And especially when you start enabling the simulation. So the simulation is not enabled right now. So if you enable the simulation, it will actually calculate probably like 10 times longer because it's actually doing a simulation. Yeah, so that's about input. So next up, and the last thing that I mainly want to talk about is about instancing. So how do I now place my models on the point cloud? So I have my terrain set up, materials work nicely, I have inputs that I can control and play around with, but now how do I actually start placing these models there? So we have our network, and here is my instancing system. So, but first, let's build this from scratch as example. So let's grab some of our instancing information. So for example, the trees. So here, I think I have my tree information. So if you remember, I scattered around a lot of points with the height with scatter, and I want to use this as instancing information. So what we want to do from the points, we want to create a attribute. So let's find some space here. I'm going to just build it on the side here. So we're going to use create attribute. I'm going to grab my points, and I'm going to use that over here. So in this menu, we want to add some things. So first of all, we want to specifically add a name to this. And we need to use the name called Unreal Instance. If you use Unity, you will just use Unity Instance. So that makes sense, right? So Unreal Instance. It's also actually the same for that material. So if you have like the Unreal and Unity material, it will actually also just, it's basically in the naming and also in the paths for assigning that. So then it's quite similar that we also have to set this to a string, and we need to fill in again the path to this location. And it's similar to what I just shown you with the material. So we go to Unreal, and in Unreal we can, for example, grab our models here. So in this case, I want to scatter trees. So I'm going to right click, copy reference, and we have that reference now. So in here, we're going to just then copy paste this. And then for viewing only, maybe let's output the trees only. So here, let's output only this. So this is now my output, which is basically points, but when we import this, it will actually then be our trees. So let's save this and then rebuild our tool. So if everything goes right, we should only see our trees. And as you can see, this works as expected. So I have my trees now scattered around the scene. This is basically what instancing is. So we have a point cloud, and we're going to say copy this model on the point. And that's it. So this is what basic instancing is. Now you can actually do more than copying here models. You can also use blueprints to copy on that as well. Next, what is also important is actually merging the terrain and instancing. For example, with merge here with the merge node, my terrain. So this is my terrain with my instances. We will have actually a small warning here. So we have a small warning here. So the warning is saying that there are conflicting attributes. So we're going to have to keep that in mind. So here, let's take a closer look. We can see all our information. So one of the interesting things here is that my point cloud, the points hold different attributes, as you can see, and they are holding different attributes than my terrain. For example, my terrain has information about where the grass should be, but my points here only may hold information about where the tree should be and what model I should copy on this. So when I merge these two networks together, they will have conflicting attributes or information. So what is a common issue that can happen is, for example, something like this here. So we can see that we merge different data together and it doesn't know what data to fill in. So it's going to leave it blank or fill in 0. So here, for example, for instancing my models, on my point cloud, it knows exactly what to instance. On my terrain, it doesn't, because it also doesn't need instancing, so we can leave it empty. That's no problem. But this can be an issue, for example, with scaling. So we can have conflicting scaling information, like we could see here already. Now, another example of this is, let's place a quick point here. So I'm just going to place a single point. And on that point, I'm going to create an attribute. And I'm going to create an attribute called scaling. And scaling is also a value which is controlling the scale of instances. So if I now would also make scale a vector 3, since it has an x, y, and z direction, let's fill in this 1, 2, and 3. So now let's merge the scale with my trees. So now let's look for the scale value. And we can already see here something interesting. So this is a problem that can happen if you don't see your instances. This can happen when there is conflicting scaling information. So here I have a scale that is conflicting. So I can, for example, quickly show this if I would now use this here as output and save here this information. Let's then recook our tool. And you can see we have nothing in our scene. And this is because there is a scaling conflict with the attributes. So here, if I actually go to my components of my tool, we actually have a certain instancing of my trees, but I don't see them in my scene. So one of the reasons for that is because the scale is set to 0 and we don't see it because the scale is 0. So it actually has an instance, so we can see that here that there are instances created. So it has that information, but we don't see it. So here we see that there actually are instances. So again, coming back here in Houdini, we have here our scaling conflicts. So we have our p-scale value, which is basically saying the overall or the uniform scale of an object. And then we also have the scale value, which is specifically scaling the x, y, and z of a model. So if I merge something which the point here doesn't have p-scale in it, and the trees don't have scale, it only has p-scale. So here what will happen eventually is here this issue where my p-scale is 0 So on my single point here, the P scale is 0, and on my model here with the trees, our normal scale is actually 0, 0, 0. So that's basically an issue that can happen. That's something important to keep in mind that could happen. And this could also happen with other things, for example, with the rotation, for example. So here with the rotation or the orientation or the normals, this can happen as well, where certain values could be 0 if you don't define them. So that's something important to keep in mind. So let's delete this here. And I'm going to show you some examples of how I set up the final instancing now. So here for the final instancing, here are some of those examples. So here is the fence. So what I did first for the fence was creating a P scale value of 1, then also setting a overall scale value of 1, and then I convert the normal to a orient attribute, because I personally prefer to use orient instead of the normal vector to correct the rotation. So you could see that normally, if I would zoom in and maybe go here to the scale, we can have a normal direction, as you can see, to guide my model's orientation. Then I'm also splitting this up. If you remember correctly, I had like a stone here, so I had like the fence, but I also needed a small pillar at the end. This is basically what I'm doing here. So this is again the whole fence model, and this is then only the end here where I'm going to place a pillar. So this is the process of creating that fence. Now creating the trees is then very similar. I'm going to also make sure I have an orient available. In this case, I already had it, so that might not change that much. Also, if you are looking forward what's in here, it's basically using the normal, making an instance transform. You can also use the up vector, and then converting the matrix, the X4 matrix, to actually a quadhedron or vector 4. So that's what I'm doing there. Then for the trees, I'm also going to here add a Unreal instance, but I'm going to randomize between multiple trees. So this is quite interesting, is that we can use the randomizer on custom discrete here. So custom discrete, and set it to a string, of course. And we can give multiple values. So I can add more if I want to. I can add more of them. So we can have multiple variation in trees. So they are not all the same. And then when I have that, I'm going to also add a scale value. I'm going to add also some custom randomization in there. Then for the tombstones, I did the same thing where we have the custom discrete, and we're going to add multiple variations here. I'm also going to here use then a scale and P scale value. So I'm also always going to double check, is there any scaling and P scale value available? So I don't have that scaling issue that I just showed you. Then I also have then my tomb. So again, same process, converting, making sure I have my instance. We can have here specific blueprint, and we also then here have then our scaling. So that's basically how it's done. So we have all these instances. So I merged them. You can see that there might be some small warnings. So as you can see, there are some issues, but if they are not directly infecting the scale or direction, then it's fine. This is also for the fast mode, since I don't want every model in the fast mode. Then I'm also using the add node to get rid of any other geometry. I just want points. And this is then my result. So the final output here is first, this is important, first my instances, then my terrain. Always keep that order. That works for me most of the time without any issues. First instances, then the terrain. And then we can now save this, and now we have our full tool. And let's talk a bit more about the tool then in Unreal. So now with that set up, let's then quickly rebuild this. And then we should see now a final result with everything ready. And we see then our results. So as you can see, we have the things ready. So here the cube, maybe also enable actor hide in game. So we can actually see what's going on here. So that it works. Now, let's also look a bit at the instancing. So here I made a specific menu for instances, so I can have or control here what models I should use. So if I quickly jump into Houdini, so if I go into my interface, so here at the bottom, I created these instances. And again, you might have seen this, that I've actually, you know, like I can just drag and drop these in the interface. So again, if I would, for example, would like to have here like the tombstone, if I, for example, would like to have another tombstone variation, I can just here grab this and add this here under tombstones and call it tombstone number 7 or something like that. So this is how you can create that custom interface. So what is interesting here in Unreal then is that we can actually drag and drop these models in there. So currently I'm using static meshes, but I would like to see the blueprints used. So I can just drag and drop the blueprints in there. So I'm just going to drag and drop them in here. And you see that my scene disappeared, but it's also recooking here as well. So I'm going to drag and drop. So you can see that the tool will automatically always try to stay up to date and calculate things. I think I missed one. So we have that ready to go. And you can see that also one of my blueprints is actually a small, I would say, gameplay element where I have a trigger. So this is a collision trigger, and when the player walks to it, the hand will basically come up and break through the stone. So let's test that in game. So here, I, for example, have one of these triggers. So I'm pressing play. And when I walk close to it, it will actually then creep up. So here the same, it will then show up. So it's just like a cool thing you could do here as well. Like this is also again like a blueprint with like lights and particles. So to make it a bit more foggy around this area. So you can play around with these things. So again, like you can instance blueprints, particles, lights. So you're not like limited to static models. You can just, as you could see, like have blueprints also automatically placed around. And again, you can use gameplay elements, like you could scatter around certain props that have a certain gameplay interaction, like you see here with like the collision thing. This is just like a blueprint. So the thing also about blueprints is that I can actually now grab this and place this around. So with a static mesh, this will not be possible always to actually grab it. As you can see, for example, I cannot just grab one single tree or one single fence, since this is really like an instance area. So these are all different blueprints, so we can grab them separately. And this is then basically my tool. So again, I can change the curve here, so everything is perfectly along that curve. And to finish off my terrain, I would then also enable here the simulation here. So the simulation will make it much better, since it will also simulate some grass here and some dirt here as well. And you can see that the simulation is already done here. So we'll make it a bit more bumpy. And I might notice an issue here that I need to reset the simulation since it still has some information from my terrain in Houdini. So what we could quickly do here is go to Houdini, and in Houdini I still have my menu open, so I can go here to the simulation, and I can drag and drop the button into my reset here. So if I would go here and then simulation, and then just reset simulation and pressing apply. So now if I would recook my tool, we should see the button. So I can now just click reset simulation, and it should like calculate the tool. And here we go, that already worked. So you can see it automatically will add more of that grass. So we will have some more grass details. We are basically done with the overview. I'll also notice here that my border is not showing up, so that might be an issue with the instancing. So fence, and I think I have here 2 times the same model. So again, we can go to models, grab my pillar, fill in my pillar, and done. So of course my pillar needs a specific pivot point, as well as my fence. They have like the specific pivot point in the stone here. So they can easily spawn and rotate like this, so I can have more control when I procedurally place them. So this is basically an overview and a detailed view of how I brought this in the game engine, some setups you could do. And again, there is so much more you could do, and I can recommend you checking out the documentations for that if you want to see more information on what is possible with this plugin. Thank you for watching, everyone. I hope you enjoyed this information about how to build a scene and how to actually use Houdini Engine.
Hello everyone, and welcome to this Houdini HIVE workshop. My name is Erwin Heyms, and today I'm going to talk to you about user-friendly production tools for procedural pipelines. So, I'm a technical artist, and I've been working at Ubisoft for the past 8 years at this point. I've worked on Ghost Recon Wildlands, I've worked on Ghost Recon Breakpoint, on the procedural tools pipeline, and most recently, I've been working on the Riders Republic. And then next to that, I'm also a Houdini teacher and mentor, and I've been for the past 5 years. Around 2017, I started making this course while I was inside Ubisoft. And I eventually developed this into a 35-hour Houdini Core Masterclass, a video course that was shared with the entire company and pretty well received. And since then, I've done some basic lectures at, say, for example, at MIGS. I had a master class in 2018. And most recently, I've been working on a new public master class in my own spare time. And this is under my own venture, eHoudini Academy. And this is called the Procedural Asset Production Masterclass. So a little bit about that quickly before I get started. So what I'm working on right now is this large multi-stage masterclass. It's going to be several modules, and it's going to take people from beginner level to professional skill level, or at least the skill level I personally believe I have. And then I want to release this over the course of this year and into next year, with the first module released right now for free on my YouTube channel. So I'll talk more about this later, but basically a lot of the things I'm going to show you, a lot of the images and content in my presentation are from my masterclass. So that's where you can find some more information on it. So as for the workshop content, what I'm going to talk about is an overview of tool pipeline solutions. So basically, how can we build up a procedural pipeline for our games? And what are some of the practices and the types of tools that we can build? Then after that, I'm going to talk about and show you how to make a cache-based pathing tool. Now, this is going to build further upon the last workshop that Simon did. And this one's going to involve creating a little tool that allows us to draw paths and then save the results out to a cache and then iterate upon that result. So it acts somewhat like this, where we have a basic drawing capability. We can click points, it will path along the terrain, and then we can save that out and it adds it to the world. Next to that, after this workshop, I'm going to have a breakdown of a PyState object editor, and I'm going to break down how this thing is built, some of the most important parts on how to construct it. It's a bit too complex to talk about in terms of Python code specifically, but this type of tool is more than just Python code. you need to build an entire system around it to make it work. And I'm going to highlight how this is constructed. And then hopefully you can take it from there yourself. Plus, like I mentioned, I want to give you a basic preview of the masterclass. So with that, let's begin. So the first thing I would like to talk about is tool pipeline solutions. So when I think about procedural tools, there are a couple of types of tools that I like to discuss. And these are basically archetypes. So the first one is the canned asset, basically a standalone plug and play tool. You can just drop it down somewhere and it will work. Then next to that, we have processors. So these are larger tools. Usually they're too heavy or too memory or time consuming to cook. So they have to be run on a render machine. That isn't mandatory per se, but these types of tools I put in a different category. Then we have the editors. These are usually a combination of various tools that facilitate an interactive workflow. They're lightweight to work with, but can be very powerful because they can make use of the ability that processors offer, for example. And then I also want to quickly talk about utilities. Basically the simple, robust sub-assets that in larger projects you tend to build to make things a bit easier on you, automate some simple tasks. So let's go over each one of these topics and go a bit more in depth. So the first one, like I mentioned, is the canned assets. And the canned assets are basically these tools that you can just drop down into your scene. If you have the Unreal Engine, you can grab it from your content folder, drag it into your scene, and it will start building something. For example, this is an elevator builder, and the idea is that you can just drop it down and configure it, and it will just run. And these things can contain all kinds of information, such as, for example, you can feed it information that can be gameplay related. In this case, the doors of the elevator, as well as the elevator itself, get configured. So you can actually traverse it. And these types of tools are very simple. You have inputs on them, usually parameters, maybe curves. You can have some geometry or terrain, and you just drop them into the world. You link them up to whatever input you have, and it will run. And this is very easy. These types of tools are quick and easy to hand off to your artists. These are probably the first type of tool that you'll ever encounter if you have never used a procedural tool before. Now, as for integrating them in the pipeline, well, we can use the Houdini engine. It's very simple. In Unreal, we just need to have the Houdini engine installed. We drag and drop it in the world and it'll work. And from there, well, most of the time you remove the asset after you're done, and then you have whatever you generated, like mesh data or instances. So the next type of tool that I want to discuss is the processor. And the processor is a type of tool that is best run on a render farm because of its size or because of the volume or memory load of the data that it needs to process. So let's say you have, for example, a large open world and you need to cut all your data that you have and group it into tiles for optimization for streaming. Well, then a processor will be the tool for your job, right? Other types of tasks could be optimizing LOD on large volumes of information, large volumes of meshes, for example, or just processing textures, like layering textures and compositing them together. That's what would be a great task for running on a render farm machine. So these types of tools take data from somewhere on your server. This can be in the form of textures, but it can also be in the form of curve caches that you've drawn somehow by hand, and then you have to run that through a processor. And then at the end, of course, these tools will output the data and they will store it somewhere. So it could be stored on a folder or on your server, for example. And then once it's done, you have all your data at the ready. So these types of tools in general integrate very well in a pipeline because you can offload them to a render farm, and they tend to have easy controls. Your artists don't tend to really know they exist. And they can be managed through site apps like HQ or task operators, for example, in Houdini. Now, these tasks can be cooked daily or on demand, so you can use HQ to also trigger cooks by hand. Well, this output data that the tools produce can then be loaded back using loaders. So you have the data now stored on a cache somewhere, and you can have a loader that can then load it into your tools, or it can load it into your game engine. Plus, if you have a processor and you're processing all this data anyway, you might as well output all kinds of metadata about your world. So if you have a large open world, for example, and you're processing texture maps for, say, slopes and such, well, why not also output the slope map somewhere so you can load that in easily from somewhere else. Now, the next type of tool I think is a very powerful tool, and that's the editor. And the editor generally combines the different types of tools together. So in this case, they usually contain a very user-friendly UI, and you use data caching in order to allow very fast iterative workflows. And that's actually the type of tool that we're going to build in today's workshop. In general, you can use curves, you can use brushes, or even PyState, so Python written handles for your viewport in Houdini, to quickly manipulate your data on screen. And then once you apply your changes, that change gets saved back to a cache. So it's very iterative and designer focused. Like here on the right, I have a basic brush, and then my placement system for this kitchen assembly uses that brush as a placement location, and it moves the kitchen from its current preferred location to this new zone, and that's very fast. So in general, these tools need to be lightweight. You need to make sure that when you build them, the data that you're processing isn't going to bog it down, especially if you're using Python viewer states, because, well, if you start drawing and it has to cook half a second or longer for every tick you make a change, then your tool isn't very interactive anymore. So making your tool lightweight is important, requires a lot of optimization. Now, in general, I think these tools work very well when you need to give them to artists, because the input tools themselves are often relatively simple to use and quick to iterate with. Well, I think artists prefer these types of tools over the ones that you just drop down and then you have to configure parameters. But it depends, of course, because it also depends on the visual feedback that you set up for the tool. If your tool doesn't give enough feedback about what it's doing, then the artist might not like it, right? So next, they can also be a bit limited depending on how you build them. Like, for example, Python viewer states cannot actually run in the Houdini engine because there's no API connection there. As far as I'm aware, you can't install them in the Houdini engine. So these types of tools would then be limited to the Houdini viewport. Now, you can still take the data that comes out of these types of operators and then run them through HQ using a processor. So the editor portion can be a very lightweight piece that runs up front of what you are basically trying to process. So if you're trying to process roads, then the editor portion would be the drawing utility. And then the processor will be what comes after that drawing utility that processes all the information into the final results. So the editors are the part that your artist sees, and the cooking part that comes after, they don't actually have to deal with. Now, lastly, we have the utility assets. And the utility assets are these types of tools that facilitate a particular thing that Houdini doesn't do quite right or can't do at all, right? So think of, for example, importing meshes from a game engine. Oftentimes, we need to have a custom solution for that, and that's when we need to write this plugin that does that for us. So that would usually be a utility. We don't tend to hand these off to our artists in our team. In general, they don't even know they exist. But us as technical artists, we become very familiar, and we tend to use them all over in our pipelines. Other types of utilities we can think of are the types that improve upon existing Houdini nodes. So ones that add or improve upon Houdini's functionality. Over here on the right, for example, I have an asset that facilitates some of the cutting behavior that you might get from a Boolean shatter node, or an intersect stitch node. But instead here, I took some of the combined functionality of the intersect stitch and the poly split to make a more robust version of a cutting tool, where you can just take any kind of surface or a line and then subdivide a piece of geometry with it. And if you do this properly, and you make these tools robust, then you can use them all over your pipeline and you can share them with people. And that's probably the most powerful part of utility assets, is the ability to just make your life so much easier. Stop having to worry about creating workarounds, for example. Now, if we think about utility assets, then there's quite a lot of them actually in the Labs toolset. It actually provides features that Houdini doesn't do by default, like extracting a curve from an edge group, for example. Simple stuff, but it doesn't come by default with Houdini. Now, as for integrating these into your pipeline, in general, it helps us integrate our tools better within game engines. Like I mentioned, we have the ability to import data or perhaps export some form of data from Houdini to the game engine. Well, that's where they are very powerful. And because we can share them amongst ourselves in our team, oftentimes the code of these utilities tends to be improved. Like someone sees a feature that needs to be improved, well, they improve upon it, or they make a version 2. And this allows us to speed up our tool development, as we're basically improving our tool set besides Houdini's tool set over time. And it will make these robust and powerful utilities that we use everywhere. All right, so in this next part, I would like to talk about how we can take these different assets that we just discussed and how we can turn them into a pipeline, how we can make them work together, and what role metadata plays in this as well. So the way how we build up our pipeline actually greatly affects how the final development structure of our team is going to work. If we set out to create a project with a very heavy processor-based pipeline, then we might need to set up a scheduler and run this during the night so that people in the morning have the latest data baked out and ready to work with. Whereas on the other hand, if it's a very canned asset, like drag and drop type asset, a heavy pipeline, then we need to teach these people how to use these tools. Depending on the way how you plan to use the tools and how they interact with one another, your pipeline is going to vary greatly. So I just want to discuss a couple of methods on how we can make these pipelines work. So the first type would be if we try to run tools in tandem or as batch jobs. And these heavily rely on having a wrapper asset or a larger tool that has subtools inside. And I'll quickly go over what this actually means in a minute. Then we also have the sequences, which would be if we run processors in, say, HQ. And then we also have these intermediate loaders. And in this case, we have a side asset that gets data from another asset. We process that information either automatically or customized by hand, and then we send it back to the main asset, kind of like slotting data back into the main asset. But regardless of which one you're using, they all heavily benefit from metadata. So information that the tools generate and then share with one another. And this allows us to make our pipelines much more responsive. And it gives us much more options about how we build our tools, because we have all this information about our game or our game world available from all the different tools that we use to build it. So the first type of method I want to discuss here is when we run tools in tandem. And when we run tools in tandem, it basically means that we are nesting them inside one another. So here on the right, you can see I have this elevator and a staircase over here that are being generated inside of this atrium environment. And the tools themselves, the elevator and the staircase, are both subtools. They are both standalone canned assets, but they also have this functionality that they can be hooked into a bigger asset as well. And this tool, it has the ability to slot them in there. So we have these slots here on the right that ask for these particular assets, and then they get configured and then they just run. And by the end, at the end of this loop, we have a fully functional elevator and staircase, no matter what the shape of this atrium, because the atrium configures the tools. However, when we do build this type of tool, we need to make sure that the subtools are lightweight enough to run in this kind of configuration, or they might heavily bog down the final result. So a couple of pros versus cons in this type of configuration is that nested tools can be very heavy. They need to be light, and if they're not, then they will bog down your cooking. So you might need to set them up on a processor instead. On the other hand, if you run them in editors, which is where I think personally they work very well, then you can rely on cached data to make your tools faster. An example here could be that the elevators get generated and then the result of them gets saved to a cache. And then this cache is what's being loaded by the bigger tool. Yes, you need to regenerate the elevators if you change the shape of your building, but at the end of it, you don't have to worry about what they've cooked. They just ran and they're done. So the next type, or the next method I want to discuss is batch jobs. And when we run tools as batch jobs, we're basically running them using render operators or topnets, so procedural dependency graphs. And this allows us to very quickly generate a large variety or a large range of data from one asset. So one example would be if we use a compositing utility, for example, which takes different layers of terrain and all kinds of tiles, and then processes each of those over and over and over again until we get all of our tiles completely rendered. But next to this, we can also think of it as, say, a batch operation for a subtool. So in this case, here on the right, I have this tile builder, and I have all these variations of tiles. And they're all being generated from the same base shape. So this could be a mesh we load in externally and then run through this tool to cut it into the different tiles, or we can generate a mesh procedurally and do the same. And this is a very good suggestion for if you want to create a batch job, because the benefits of running a batch job is that you don't need to have dozens of assets in your scene to do the same thing. You just need one that gets constantly reconfigured and recooked and outputs the data after each cook. For example, here on the bottom right, I have 20 different pillars, and they're all basically the same pillar, but with a different cutout. So if we run this as a batch job, we have one asset, and then we run that through a wedge node with render operators, for example. And by the end of it, we have all these pillars. We don't actually need to instantiate 20 different assets. On the other hand, configuring them takes a bit more effort, as opposed to installing 20 times your asset and configuring each one by hand. You would have to set up a CSV file or maybe a series of nodes that you plug into a merge node, and then you run the iteration using the data on those nodes. But of course, this way you don't have to worry about configuring everything by hand either. And if we were to run this using a task operator network, we can also distribute this over a render farm, and that makes it even faster as well. Speaking of task operators and HQ, over here on the right, we can run our tools as sequences. And when we run tools as sequences, it basically means we have a manager somehow, or a scheduler that triggers our cooks, that manages our tasks. So we can set up different tasks and schedule them together. So one series of tasks that completed, and then the next one and the next one. And eventually we output that data. So the pros and cons of this would be, it's easy to load data that's already pre-generated into a game engine, but it is susceptible to corruption. So if a cook on your render farm fails, it might have a domino effect down the line, and you might need to re-render the entire batch. And that can be especially frustrating if it takes an entire night to do so. On the other hand, you might also need a dedicated data manager, because the more tools you have and the more data you need to manage, you'll need someone who knows intricately how this sequencer is set up. But overall, the benefit is, of course, that if everything works properly, you don't have to worry about anything. Like your render farm will just take care of everything, and the sequence you've set up will sort it all out for you. So the next type of tool would be if we create loaders. And loading or side loading would be when you take information from a tool, split it out, such as in this case over here on the right, I have this bigger building and I have this shape for an atrium. And I export this shape out to an external file and then load that into a separate tool. I can then use that separate tool to construct a custom atrium space and then save that back out into a file and read it back into the master tool. And as long as that configuration hasn't changed, it will fit in there and just connect up to everything. So this is a way to inject custom work inside of a much larger tool. Now the benefit, of course, for this is that loading it is much faster and it allows for more manual work. You can also debug the results of your subtools this way because you don't rely on the main process, say the larger tool, to cook out all the data. So you have a much more responsive and more predictable set of data. However, of course, the results are static. So if your building is going to be changed in this case, then the atrium might not fit. And you'll have to restart all over again with making your own custom space, right? So you probably do this at the end of the process when you've already designed the shape of your structure and then want to inject this very customized space into that larger building. All right, so at this point, we've basically come to the part where we are going to start building our cache-based pathing tool. And this is an editor, just like I described earlier. And it's basically going to allow us to draw paths inside of Simon's little graveyard. And we can do this using an input curve. We just move the points and then we can add segments. And we can keep adding them because every time we add a segment, it gets added to the cache and then the load node takes over and updates whatever we're working on. Plus, we will also have the ability to remove segments. And this system is built up out of three main parts. First, we're going to build the grid and then the recursive pathfinder. And these are the two main systems that allow us to draw our paths, right? That's the main tool component. Then we're going to work on the save load system that allows us to save our information to a cache and then retrieve it again and edit it. And then finally, we're going to add the UI and visual feedback systems. So let's get started in Houdini. So if you're starting on my course and you haven't followed Simon's course, then you can get the file straight from the side effects site, wherever we get the files for the course from. If you have followed Simon's course and you would like to continue with his file, then you can do that, though I suggest you start with mine. But basically what I've done is I've taken Simon's file and I've added a couple of changes. I haven't touched his tool or any of his other parts here, but I've basically just set up some obstacles for the Pathfinder to avoid. And next to that, I've hooked up my own tool into his. So I've done that by grabbing some information from the graveyard asset and then object merging it out using these object merges, such as his terrain over here. And I'm grabbing this from the cleanup layer games engine node, which is located here inside of his tool. That's for the terrain. And then next to that, I've also grabbed some obstacles. Firstly, I've grabbed the boxes that I'm using for the tombs. And then I've also grabbed the copy the points for node inside of his network, which contains the fence. So this one actually copies the fence pieces. And I need this because I need to make my Pathfinder avoid the fence and the tombs. Everything else in the scene is going to be based on the paths, but these particular elements are hand drawn and I want to be able to avoid those. So for the rest, my tool itself basically just generates paths based on the terrain, a little pathfinding grid that it generates inside of this square. We can modify this square by either plugging in a box and then drawing out our own custom pathfinding area. or we can leave it out, and without that it tries to pathfind in the entire map. Though this might be a bit heavy, so I'm going to keep it plugged in. Next to this, if we look over here on the left, I have a couple of merge nodes set up, these purple ones, and these are to give you visual feedback. I've merged in his terrain, as well as the visual output from the cache-based path editor. So if you look on the right one, this path visualizer, this is good for when you're working with the tool. It's very responsive. And then on the left, we have all the visual information, such as the trees, the tombs, and the gravestones, and that's all present there. Plus, over here on the right, we have an output from the pathing tool, and this one provides us with the path network itself. I've added a stash node in between as well, so this acts as a buffer between my tool and the input to Simon's graveyard tool. Okay, so at this point, I'm going to start talking over the existing video I have, and I'm going to speed it up and slow it down when I need to. So first, let me walk you over how the tool works. If I lock my screen in place and then I can grab my drawing curve, I can start drawing new segments. This will create new paths between the waypoints. And I can move the waypoints around, as you can see. It's quite responsive. So there's also a couple of settings. The first one here is the snapping strength of my different waypoints, and they will snap to existing segments of the roads into cache. Then we have the magnetize to cache feature, and this acts like basically a magnet for the new roads to make them follow existing roads in our world. If I set this to maximum or 100%, then you'll notice that it will snap to the existing roads instead of pathing the last segment directly. So that means that the roads will follow along until this point, and then instead of pathing to this last segment here, because magnetize is set to 1, it's going to actually back over itself, because these are really cheap, and then it's going to follow the existing road, and then it will branch off here, because it can't go outside this yellow zone, and then path the last segment there, because this is the cheapest path. If we lower the magnetized value, however, then you'll notice how the pathfinder now branches off and follows this direct curve. Plus you'll also notice that the curve does this little bend here, and that's because it can't go up the little cliffs that are in the way. If I show my grid, then you'll see that the pathfinder cannot go up these areas. So instead it goes around. And it does that because there are a couple of other settings in play as well. But first here, let me show you what happens if I change the grid. If I lower the amount of vertical segments of my grid, then it has even less options to go up this slope, and it really has to go around this area, even with a lower magnetized value. So this is a very easy way to limit the way how your pathfinder goes up a slope, and instead forces it to make more shallow or zigzag routes. Next to this, we can also change the avoidance behavior of the pathfinder. So this red area around the obstacles, it's an increased cost value, and it means that if we increase this range, then it'll become more costly near these objects. So the pathfinder can still go there, but it will just dive in and leave as soon as possible. And then the last thing here is the turning cost weight. And the turning cost overrides the cost of turning. So every single degree it has to turn, it will increase the cost by this amount. Whereas this value here increases the cost per grid segment near an obstacle. So if you add those two up, the pathfinder will try to avoid obstacles, and it will try to avoid making as many turns if these values are very high. Now, as for using the tool, it's very simple. All we have to do is draw a path. Then we can click this add segment button, and this will add it to the cache. And then at that point we have this added to the cache, so we can now start adding new segments as well. Plus, if we switch it to removal mode, we can then place 2 points or more on our existing curves, and then it will path between those over the network, and then we can remove that segment. So you see how it just vanished? The new roads now are marked as removal because that's the only path between these points. Plus, there's also this yellow box, the optional bounding box input, and this changes the area in which our pathfinder can path. If we disconnect this, it will now use the entire terrain. So this is how the tool works. And now I would like to continue with the main part where we're going to build the tool. This will take a little bit longer, so like I said, I'm going to speed up the video when we get to easier segments, and I'll go in more in depth and slower when we get to more intricate segments. So let's disconnect all these parts and remove the tool, and now we're ready to go. Alright, so let's get started. Let's create a new subnet node here. I'm going to drop it down, and I'll call this one the HIVE cache-based path editor. Now I want to turn this into a tool, so let's copy this and create a new digital asset. I don't really care about the path location right now, but let's make sure it has the right name, and then let's click accept. And this will create a new digital asset. So for this, I need to add 4 input parameters, 1 for each of these different inputs. So let's go to the basic tab and set the maximum inputs to 4 and the minimum to 3. So that's 1 for the drawing curve, 1 for the terrain, we have the obstacles, and then the bounding box. For the outputs, we need 2. So that's 1 for the visualizer and 1 for the path output itself. Let's go here and let's give them some names quickly. So we have the editing curve, the terrain is the second one, obstacles, grid area, bounding box, and then the last 2 are the out for the visualizer and the out for the paths. Now here I'm going to click apply, and let's connect everything up. Plus here on the left I want to connect these up so that later on I can work with them. Right, so now let's dive in. Let me delete this node and place a couple of null nodes down. I'm going to set up the inputs for this tool, and I'll do this a bit quicker. So let's create a couple of null nodes and connect those up. I'm going to name these based on their inputs, so they're easier to recognize. And what I also like to do is add a bit of color to them, so they're easy to recognize from a distance as well. So I'll color the bounding box yellow, the terrain green, the obstacles red, and the input curve blue. Now let's grab the bounding box and the terrain, let's move them on the left, and then place the input curve on the right. And with all of these, I can now add them to a subnet. So these are going to be our main inputs. I'm going to name this subnet inputs as well. So at this point, here we have the bounding box and the grid, and I just want to determine the actual size of the grid that we want to make. So create a bound node, and now I have a basic bounding box representation for our terrain. I'm going to grab a switch, and what I want to do is if the left input is empty, I'm going to use the bounding box from our terrain instead. So let's give these some names. Now in the switch for its script, I'm just going to give it a basic n-prims expression. So this will be if n-prims is 0, then use input 1, and otherwise use input 0. So like I said, if the bounding box input is empty, it will use the terrain instead. Now let's create a null node, and this null node is going to be a data carrier that I can reference. So I'm just going to call this blue. And now we're going to create our grid. So for starters, let's create a grid node. I'm going to call this one grid points. And I need to match this one to the size of our bounding box object here. So I'm going to grab the grid points node and create a spare input. And I'm going to copy the path from the path grid size in there. So now I have a spare input link created. I can simply type a bounding box expression in the size and say bounding box -1 is d_x size. This will give it the same size in x, and then we just copy this and put it in the other channel and set z, so we match both the x and z size as well. So now depending on the size of our path grid size node here, our grid will have the same size. Next, let's add a centroid expression on the center channels. So we have the x reference. Let's call this correctly, centroid. Then copy it over to the other channel and set that to Z. So now it will match the position as well. And last, I also want to make sure that this grid sits on top of my terrain. So I'm going to grab the get bounds from terrain node here, add a new spare input, plug that in, and then I'm going to reference the bounding box of that using -2 and its dy max coordinate. So now our grid will be on top of our terrain. Now at the moment I have too many, or too little points actually. Let's grab these two channels. I'm going to grab the second size value, plug it into rows, and then the first plug it into columns. And this will now match the points based on the size of the grid. So this will give us a basic set of grid points. And I've also switched the grid over here to point mode. Next, let's create a fuse node, plug it in behind the grid points node, and we'll call this snap to grid. And for this one, let's switch it to grid mode and give it a size of 5 on its grid spacing. And this will cause our grid to be snapped to a sort of virtual grid. And the benefit of this is that no matter where our grid is located, the points will stay in the same place. So now if I move this value around, then you'll notice that no matter where the grid is located, the points will stay in the same locations. And this is useful because we're going to use this point grid to create our actual grid connections, and we don't want those grid connections to be in different locations if we have a different input. This will allow us to work with our cache easier, because we need to match the paths in the cache to the grid later on. So next, let's go ahead and snap them over to the actual terrain. So I'm going to create a ray node. I'll call this one ray to terrain. Let's plug this in. So we grab the terrain on the second input, and let's change the direction so it casts ray downward. So let's set the Y channel to -1. And now you can see how it snaps down. Plus, if I use the entire terrain, you will notice that we have these points on the outside that aren't snapping. So I want to filter those out. Let's go ahead and use a ray hit group from the ray node, and then use a blast node to remove those as well. So we're just going to remove all the points that are outside of the ray group. Okay, so with that, we now have our points ready. Next, I want to process the obstacles. And to do that, here we have our obstacles, and they're coming from our object merge outside. And I have a silhouette from them using a lab silhouette node. So I'm going to grab my ray node, copy this over to the right here, and then I'm going to grab the channel from my terrain and position it right here. Next, what I want to do is grab a labs match size node, and this one will allow me to position the obstacles above the terrain, just like I did with the grid before. So here we have the grid offset. Well, I'm going to grab this match size node, and I'm just going to use it to change the Y channel. But I do want to leave the X and Z channel alone because I don't want to offset those. Let's change the Y value to max, and now the obstacles will always be above the terrain. If we plug this into the ray node, then now the obstacles will actually sit on our terrain, and that means that we can now use them to obstruct our path points and remove some of them. So next, create a transform node and a poly extrude node to create a basic obstacle geometry. Let's lower this down, so let's say by 5 units below the terrain, and then let's add a poly extrude. We'll just call this poly extrude collision, and I'm going to transform these up in global space by 10 units. So we have 5 meters below and above the terrain as collision space. That should be more than enough. So now we have our collision objects. Let's go ahead and remove the points that are inside of them. And to do that, I'm going to use a attribute wrangle node to write a little script for that. So I'm going to plug this in. Let's grab the points on the left, and then the second input is going to be our collision object. And I'll call this one the get distance to obstacles and remove them. So for this, the first part we're going to write is actually to get the distance from each point to the obstacles. And this is pretty simple. So let's say the float value, float at distance is the XYZ distance of input 1 to our current point position. So basically, input 1 is our collision object, and then the point position is the current point we're running over, and the XYZ distance will simply get the distance between those. So let's add an annotation to that. Let's say get distance to obstacles. And the next part is a little bit more involved. We need to write a little if expression to check if the distance is too short based on a float channel. Then we remove them. So let's say if the float distance value, if it is less than the channel reference of minimum range, then we remove the point. So let's add some brackets and let's say remove point. So we reference our own geometry and then the current point number. This means that whatever point is within our range will be removed. If we click the button here, we can add a new control. And if we increase that, you'll see how the points are being deleted near our obstacles. So I'm going to set this to 2, because 2 meters is about enough. Now you'll notice that we have a couple of points inside of our obstacles, and that's simply because just the distance between the point and the hull is still bigger than 2 meters. So instead, I'm going to reference the ray node instead, which is a flat silhouette shape on the terrain, and that works a bit better. So here it's connected to the collision hull, and if we switch it to the ray node instead, the flat shapes here, it will deal with it better. So let's plug that in and you see how it removes the points properly. But I still need this collision hull, so we'll use that for this next part. So now that we have our points properly set up, let's go and connect them. To do this, what I'm going to do is go over to the example file, and I'm going to locate the find shortest path example file. And this find shortest path SOP is a SOP that I actually co-collaborated on when I was running my internship at Side Effects in 2013. And I created a couple of example files for this node. And the one that we want is called the path analysis node. So let's launch this, and this will open up a new Houdini session. And this is the example file for the find shortest path node. And this will generate a grid and then path over it. Now, if you want to check out this file, go ahead. It has a lot of information about how to use the find shortest path node. But what I'm looking for right now is this node here inside the environment and grid area. And this is the create ground connections wrangle node. And this creates the grid between the different points. So I'm actually after this one. Let's go ahead and grab this and the clean node as well. And let's copy those into our new scene. So we have the points on the left, let's plug that into input 1. And then our obstacle object and plug it into input 2. And now we need to configure it. So let's set the range here to a search count of 20. This matches our grid size of 5 meters distance. Then the primary search radius is going to be 12. And as you can see, we are already making some connections here. And it's avoiding the obstacles as well because of our input. If I disconnect that, you see how it moves over them. So that's all working properly. And then I'm also going to change the upper and lower range to 1 meter as default. And this will create a nice set of connections, especially around the hills. Okay, so I also have the clean node behind it, and this one is just simply removing overlapping pairs, but leaving one connection intact. So what I want to do next is grab the distance value that we're getting from our distance and obstacle remove node, and I want to promote it to primitive connections. So let's grab an attribute promote node, call this promote dist. And then let's promote the distance value from point to primitives. And I'm going to set the method to mode. Now I would like to view this, so let's create a visualize node and plug that in. And if I go to the visualize setting, let's switch it to ramped attribute. And I'm going to change this to the distance value on the primitives. Alright, so as you can see, we now can visualize our distance attribute. And I like to do this because it makes it easier to work with them. But let's continue on and let's create a measure node, because I would like to grab the distance for each connection in my grid. So let's set this to perimeter mode. If we look in the attributes in the geometry spreadsheet, we now have the distance value and the parameters value exposed. And now we can calculate the weights for our grid. So I'm going to create an attribute wrangle here. I'm call this one prim weight. I'm going to switch this over to primitive mode. And as for the code, we're basically going to set up the basic weights. So the weight is based on the distance to the obstacles. So I'm going to call this the weight value. It's a float. And then I'm going to use a fit function. So let's grab the distance as the initial value. And then I'm going to fit it between 0 and a fall off range. That's our maximum for the initial state of the fit function. And then I'm going to remap it to two different channel values. So the first one is the maximum weight. So if it's nearby an obstacle, the distance is 0, it's going to be a maximum weight, and otherwise it's going to be a minimum weight. Let's just, it's basically a basic fit function. And let's create the attributes here on the right. So now we can set some of the values. The fall off is going to be 10 meters by default. Then we have the maximum weight of 25 and the minimum weight of 1. So with this, we should have a weight visible if I grab the visualize node. So let's set this up as the weight value. And now you can see that if I change the fall off value, for example, the red values near the obstacles get bigger. So this allows me to control the distance at which the cost of the grid is very expensive near objects. But I would also like to add a bit of extra cost for the travel distance as well. So let's type here ignore travel dist as a comment. And for this, I'm going to create a float value called travel dist. And this is going to be 0 by default. Then I'm going to say if the travel dist value is enabled, then we're going to write it out. And we're going to use the perimeter for that. So if the ignore travel dist value is 0, then travel dist is going to be the perimeter value. Then we can take this and add it to our weights. So I'm just going to add this in here with a addition. Let's fix this because I need to make sure it's spelled properly. Okay, so now if I enable this, let me change the travel distance to a toggle, or let's change it to a toggle. So now I can make it add the travel distance to the grid, or I can make it ignore it altogether. This all means that diagonals and slopes in the grid might be slightly more expensive. It's important if you include it as a travel distance in your weights, because that means we can turn off the travel distance consideration on the find shortest path sub. And next, what we need to do is add the turning cost. And this is to control the pathfinder's behavior a bit more, so it makes less sharp turns. Let's create an attribute wrangle. Let's set this up and call it the point turning cost. Plug that in. This one's a lot simpler. I basically just want to set up the turning cost, so it grabs the turning cost value from a controllable attribute. Let's expose that and set it to 1. Now I realized I plugged it in here as the second input. That is completely unnecessary. But anyway, you can see that I'm basically setting up the turning cost, and we also have the weights here. So now we have the basic path grid set up. Let's add this to a netbox. And I'm going to call this one the generate grid. All right, so let's save. And next what I want to do is add this to my interface. So the first thing I want to add is add a grid folder. And I'm going to do this a bit accelerated so it doesn't take too long. Let's grab the create ground connections control over here and grab the first 3 values. Let's plug those in. I'm going to rename these. So here at the bottom of the screen, I've demonstrated which attributes I'm renaming. This will allow us to change the grid setup. And here are the values that we should set on these settings. And then we have the connection complexity here, which I want to configure a bit more because this will allow us to control how the node will connect. Let's switch this over to use menu and switch it to replace. So we can grab an entry from the right from a drop-down menu. And I'm going to use menu item token as value as well. So it uses the value on the left. And the values I'm going to use here are as follows. It's going to be 5 and 4, 9 and then 8 for the label, and then 20 and 16. If I click apply and I look inside the grid from my interface, if I look over here on the right of my complexity, I can click on the different options and this will change the grid layout from 4 connections to 8 connections to 16 connections. And I can also increase this manually and change the values, but these are good default values to work with. Now I'm going to leave it at 16 for now, so this will work quite well. And now what I want you to do is quickly grab the value for the upper range and also copy it over here to the secondary lower range as well. So we change both the upper and lower range for grid generation. Next, let's go to our weights. Let's drag over these 4 values. I'm going to create a new folder here for this. Let's call this Pathfinder. The first value I want to set is the ignore travel distance. Let's grab all the other ones as well, plug those in and rename those. So these are going to be the default values for it, as well as the names that I want to give them. So this is the obstacle avoidance range, that's the fall off. Now the default should already be mostly configured. The minimum weight is just going to be the minimum path weight, and then we have the maximum path weight as well. Let me speed this up a bit further. And then let's add the turning cost as well. So the turning cost, let's give it a minimum value of 0.001. And with all that, we have configured the grid. Now we have it over here. We can change the values on our grid. All very good. So next, let's go ahead and create a simple parallel pathfinder example. For this, I'm going to create a find shortest path node. And I'm going to plug the grid into the first input and then create a curve swap for the second input so I can do a little testing with it. Now, the find shortest path node by default uses the groups on your grid, but if you plug in a second input, it will use that instead. And we can now access the point numbers on that input to determine where the start and end points are. And it's going to try to find the closest point of that on the grid. So now if I click on the grid using my curve with 2 waypoints, you can see how it now paths over the grid. And as long as there's a connection to be made, it will output a line. So that's working quite well. But we cannot run this in a recursive loop just yet. we would have to wrap it inside of a for each node, or we have to configure our Pathfinder to have more start and endpoints. But before we do that, let's first set up our weights. So we have those coming in from our grid already. Let's go to the primitive cost attribute. And let's add the weight attribute in here. So as you can see, some of our paths just jumped. They're staying away from our obstacles. That's coming, of course, from the primitive weights node. And then next, I want to turn on consider turning cost. And if you enable these two options and add in the turning cost attribute, then you can see that some of our paths just jumped a bit more, and that's because they're trying to avoid making too sharp a turn. And then last, I also want to omit the distance from the cost, because we already added this value to our actual grid weight. And this comes, of course, from the measure distance node and the primitive weights node, which includes this value as the travel distance. So we don't actually have to use it here. And by including it in our main weights, it will work a little bit better. We don't need it here because it will simply double up the attributes that we're already using. So next, what I want to do is add a couple of extra connections. And to do this, we could, like I said, add more start and endpoints to match our input curve. And then we can switch it to a different type of method for pathing. So let's say from each start to a corresponding end. And this will basically group them. So 0 goes to 1 and 2 goes to 3. But if we want to set it, of course, to go consecutively, then we have to set it to 0 to 1, 1 to 2, and 2 to 3. If we don't fill in every single value, it will error out, of course. But this isn't very scalable. So to fix this, let's create a for each loop that's set to primitive mode. And if we drop the find shortest path node in this, we can make it loop. Now what we want to actually loop over is our input curves here. For every segment of our input curve, we're going to run one pathfinding operation. And for that, of course, I need a second input. So let's create a new input block here. I'm going to plug the grid into this second input block, the curve into the main for each input. And then I'm going to switch the second input block to fetch inputs, not to metadata, but fetch input mode. If I plug it in like so, this is going to start pathfinding, but we do need to make sure that our input curve is carved up properly. So let's create a convert line node, and this will carve our input poly line into different segments. So now each segment is going to path between its own 2 points. And if we then feed this into the Pathfinder, you can see that it now paths properly. Now this isn't a recursive Pathfinder just yet. This is just a parallel Pathfinder. And for that we need to do a couple of other things. So at this point, we have a functioning Pathfinder, but it's not quite the Pathfinder that we're trying to create here. If we want to work properly for our recursive loop, we need to use a for loop with feedback instead. And this will create a repeating loop. This is a for each loop, that's a parallel loop. And this one's a repeating for loop with feedback. So what I'm going to try to do is loop our inputs, our input curves. And then for every single loop, it's going to loop it over into the next iteration. So we're going to add to our existing result every loop. So to do that, let's go ahead and grab the curve from the top. Let's bring it down here. Okay, so let's add a point here using the Alt key to create a permanent dot. And I'm going to prepare my inputs right here. So I'm going to create a net box for that. And I'm going to call this one snap to grid. And this will prepare our inputs so we can feed them to the Pathfinder nice and clean. Let's go ahead and create a convert line node here. And let's plug that in. And I'm going to call this one convert line to segments. This will give me a clean segment for every curve I draw. So if I add a couple more points, like so, then here you can see we have one primitive for each segment. So now we have 4 segments. Next, what I want to do is snap this to the grid. Let's grab the line from our grid down. Let's create a couple of extra dots here. And then what I want to do is flatten them so I can snap them properly to one another. So if I look at this, what I want to do is snap them down and these up so they match the grid. Let's grab an attribute wrangle node, and I'm just going to quickly write out a simple flatten script. Let's grab the height from our point position first. And then next I just want to flatten the point position in y to 0. So this node will simply grab the height, store it as a height value, and then we're going to do the same thing for our grid. And next, let's grab a fuse node. I'm going to call this one snap to grid. So under this node, we're going to change it up. So instead of fusing our points, turn that off. And I'm going to set the snapping distance. I'm going to turn that off too. So it will snap to whatever is closest. And then I'm going to say closest target point. Because they're already flat on top of each other, this will basically just snap our inputs to the grid. Then what I also want to do is go down here and add a copy for the height. So this will copy the height to our input curve as well. So now that our snapping is done, let's take one of these wrangle nodes and restore the height again. And I'm just going to take the height expression and flip it around and then remove the flattened part. So as you can see now, the height is being set and it should now match our terrain. So let me visualize that properly. There we go. So now it matches it. And it should be correct in a top-down view too. It only snaps it downwards. So now let's go ahead and create a loop. Over here we have our repeat network. Let's go ahead and create a new one. Like I said, we want the for loop with feedback. And we'll call this one the recursive pathfinder. So next what I want to do is determine how many segments we want to loop over. We want to basically grab how many segments we have and then run it over the iterations of the for loop with feedback. So let's grab this value, create a null as a data carrier, and I'm going to name this null the curve count. Now let's plug this in. So I'm going to grab the curve count variable, and I'm just going to sample the number of curves. So an n-prims expression will do. So now that we have the number of primitives, this loop will run 4 times, or basically how many inputs we have. And then next, I want to grab the grid and the segments as well and feed those to the loop. So to do that, let's create a new meta import node by clicking on this button. I'm going to call this input grid. We'll change this to input type. And then I'm going to grab my grid over here. So now we have the grid information. Then let's grab it again and drop it down below our segments. Okay. And then this will give it our segments, our grid, and then we have the main loop. And lastly, I'm going to create a meta import node. And this is actually going to be a meta import node, not an input node. And this will grab the iteration count. And we do need this because otherwise we won't know which segments of our grid to filter out. Let's create an attribute wrangle node for this. we're going to say isolate current segment. And what I want to do is grab our segments, and then under primitive mode, let's type a little expression to call out the segment we actually want for this loop. So we're going to say the current primitive number, if it is not the same as the current iteration, and we can use that using the detail reference here, then we remove this primitive. So 0, primitive number, and then 1 to make sure it also deletes the points. Let's call this remove non-active segments. So now, depending on which loop we're in, it's going to grab its corresponding segment. If I quickly plug this into the end, and then I go to maximum iterations, you can see how it grabs 1 for each loop run. So with that, we can already plug in our Pathfinder. Let's go ahead and copy our find shortest path node. Let's plug that in here. Let's plug the first input into the grid and the second input into our isolated segment. And this will already allow it to path, so that's good. And now what I want to do is add this to our output line. So I'm going to add a merge node. Let's call this merge cached paths and live paths. I want to add it as a second set to the merge node, so it gets added after. And now what it's going to do, every time it paths, it's going to add it to the data from the loop and then loop it back to the beginning. So every next iteration is going to grab the previous loops. So if I change the iterations, you can see that from the input, we're actually retrieving the paths from the previous iteration. So we do now have 2 paths in this loop. This is the third loop, and it's got the last 2 paths inside the input here. And that's useful because now we can use it to determine where our previous paths are. For that, I'm going to grab these flatten nodes here and just drop them inside our loop, because I want to make sure that both the previous connections and our current grid are always at the same level. What I want to do is create a group that I can then copy onto my grid, so I know which parts of the grid are already pathed over. And this will allow me to override the grid weights with the existing paths. And then I can make those values 0 based on the magnetization value. Now to do that, we do need to make sure that we actually have the correct information from our find shortest path node, because right now our grid is made up out of lots of little segments. And as you can see, the output from our Pathfinder is just 2 very long primitives. So in order to fix this, all we need to do is add a carve node or a convert line node behind the find shortest path node. And doing this will carve them into tiny little bits that match our grid, because the Pathfinder just generates the curves from the grid it runs over. So we can actually get those connections back this way. And now, as you can see, if I refresh the loop, we now have all of the connections matching our grid. So we can use that. Let's add a group node. Let's call this one override. I'm going to call this the override group right here. And then we're going to grab a group transfer. And I'm going to transfer this at 0.01 range. And I'm only going to transfer the override group. We need to make sure we use the primitive groups for that, of course. And now if I look under the group window, the group display, I'll just give me this right color. You can now make out this curve in our grid as a group. So we can use that. Let's call this one transfer override. And now I want to restore my height, so I'm just going to copy the height restore node from up here and plug it in. And now finally, now we have our groups, we can use them to update our weights. Let's create another wrangle node. And I'm going to call this one override weight. So we're going to set this to primitive mode. And then let's say if the override group is true, then we override the weight. And we're going to use a magnetize attribute for that. So let's set this to f weight is equal to the linear interpolation between the original weight, a value of 0, and then whatever the control is. So in this case, the magnetized value. So if the magnetized value is 0, it's going to use the original weight, and otherwise it's going to use a value of 0, right? So if I lower this, you can see how the weight value on our grid is actually changing. Now we can plug this in over here. Now we just need to make sure that you set the actual group up here under the override weights. So it only applies this, of course, to the transfer override group. I seem to have mistaken here in the video. So we need to do one last thing, and that is add a removal for any overlapping paths. So if we create new paths, we don't want it to double up on existing ones. Let's create a group node here. And if the output from our pathfinder overlaps an existing path that came from a previous iteration, then I'm going to remove that segment. So let's use the same trick as we did before with the override. Let's create a group transfer, set it to a very low value, and then we'll just set it to transfer the new group here, the overlap group. So now we have marked the section that's overlapping between our two different sets of curves. And now we can just blast away the overlapping section. Now let's go ahead and add one more group here. And this is going to determine that this is a live segment. So when we're pathing new paths, we can identify them with this tag. So now we have our recursive pathfinder setup created. Let's add one more clean node to the bottom, just to be sure. And let's make sure that it removes any segments that were still overlapping from our input. This will remove any doubled up lines in our system. And with that, we have our basic setup done. So at this point, what I'd like to do is add some visualizers, because we now have a functioning pathfinder, but outside of our tool, it's not quite ready yet, right? We can see it, but it's just a set of curves. So what I want to do is have a better visualization for this. Let's grab our network here and quickly clean it up. So we add it inside of a netbox. And I'm going to call this the recursive pathfinder network. And then let's create a visualizer system. Now for this, I'm going to speed up the video a bit more because this is relatively straightforward stuff. I'm going to create a netbox down here, call this the visualizer. And for this, let's first create a polywire so we can visualize our curves a bit better. Now let's give this a color. The default color is going to be green. Now I'm going to boost the colors to 5 instead of 1, and this will make them brighter. Now I'm going to use a split node up here to split the live segments from the cached segments. And then I'm going to copy this network onto the left and make this section blue. So our live sections will be blue and our cached sections will be green. So in the visualizer we can see which parts are new and which parts are old. These are all going to be set to primitive color mode. So this way, if we merge them together, we have both our old paths and our new paths as a visual. And I'll call this one the visual for the add state of the tool. So next, I also want to create a couple of other visualizers. What I want to do up here is go to our poly extrude collision node and drag that off so I can visualize my collision objects. And let's just clean this up quickly. Let's create a color node for that. So I want to color these red. I'm going to make sure I delete my existing color attributes and set it to primitive color. Let's also add a normal, so we have a better normal representation. This should fix the normal if we set it to biface area. And then I'm going to pack this geometry, because this makes it a bit lighter to visualize. Also, I don't need all these primitive numbers in my screen if I actually decide to show my primitive numbers. And finally, I'm just going to group it, so later on I can filter out the obstacles if I want to. Let's go up here and set it to obstacle group. So now we have our paths and we have our obstacles ready. Now next I would like to visualize my grid. So let's grab the grid from the prim grid node up here and drag this down. And I just want to color it and make sure that I can turn it on or off using a switch later on. Now up here we have the visualize node that was showing us the state of our weight attributes, but the visualize node overrides our viewport. It doesn't actually add a color to the primitives. So to make it compatible with everything else, let's add a color node instead. And I'm going to switch this to primitive mode, switch it to a ramp from attribute, and then we're going to use the weight attribute. Now next I need to set up the colors, so I'm going to set this to blue, and let's make it a little pale. Then let's add a red color, and the middle color I'll just make yellow. So it's just a simple heat map type color scheme. So now I need to set up the maximum value for this as well, and to do that I'm going to grab the input curve and let's get the weight and promote it to maximum, and then reference it by the color node. So I'm just going to use a spare input here to the attribute promote, and I'm going to reference the weight value. Let's promote it to a detail attribute, set it to maximum, and then I'm going to just type in here a detail expression to grab it. That will give us the maximum weight value for this node. So let's add the switch next, so I can turn this on or off in my viewport. I'm going to call this show grid, and with that let's add it to a subnet, call it the visualize grid, and then I'm going to plug it down below. So now we can turn on and off the grid in our viewport as well. And the last thing I want to do is just grab our grid points here. Let's copy this. I'm going to call this grid edge and turn it into a mesh. And then I'm going to remove all these subdivisions, so we only have the edge. Then I'm going to resample this edge. So I have a lot of points on my edges. Let's say every 20 meters should be good. And then I'm going to resample it by the polygon edge, so we have a clean subdivision across the entire edge. If we then grab the ray node, it will snap to the terrain, and then we can use a polywire to visualize it. And let's add a color node, so we can make this bright yellow. And then let's plug that in down below as well. Let's call this a visual edge. And with that, we have our visualizer for the basic pathfinding system pretty much complete. Now let's go ahead and test out the basic pathfinder system. If I use the connection points, I can path in our scene. And for here, we have our bounding box. So I need to make sure this is actually connected properly. There we go. So with that, now I can determine the size of our grid and path in very specific parts of our scene. Alright, so it's already working. As you can see, it's avoiding the tombs inside of the graveyard. Okay, so with that set up, let's go ahead and add the magnetize control to the interface as well. And with that, we should have our basic pathfinder setup complete. Let's go ahead and go to the magnetize value inside of our loop. And I want to promote this to the interface. So I'm just going to add a couple of separators here, so we have it separated out. Let's click accept. So at this point, we have our Pathfinder ready, and next what I want to do is add the save load system to this node. So we can start adding and removing our connections to our cache. Let's go here below our Pathfinder, and let's add a ROP output driver. Let's create a ROP geometry output node. And this node is going to save out whatever we've pathed and save it to a cache. Let's call this one the save add node. And then let's go ahead and plug the Pathfinder into this, because we need to create a little bit of data for our cache. And I'm going to save this to a cache path. Let's add that one to our type properties. So let's grab those. And I'm going to promote the output file path up here to the top of our editor. I'm going to call this cache path. And as for the default value, let's switch this to the current HIP file. So let's use hip/go/pathcache.bgo. This will save it to the same location as our scene file. Let's go ahead and apply this. And now, if we click the Save to Disk button, and now it will have saved it out to my hard drive as a BGO file. So next what I want to do is load this file again. So let's grab a file node. And let's call this one load path cache. So I'm going to copy the path from the ROP output driver and paste it into the geometry file field of the file node. And we need to make sure this is in backticks so it evaluates properly. And you can see we're now loading our file. Now in case our file is missing, I also want to turn off the missing frame because I don't actually like it when it generates an error. I don't want it to crash the editor. Let's turn that off. And then I'm going to call this blue because that's a color to me personally as a data source. So next what I want to do is make sure that when I save, I want it to reload the file node. And to do that, I first need to promote the file nodes button, the reload button, to the interface. So let's go ahead and do that here. And I'm going to call this one reload cache. So now we have this reload button on our interface. And whenever I click that button, it's going to force the file node to reload the data. So next what I want to do is add a little link using the post render script from the ROP geometry output node. And that will then trigger the file node to reload whenever we save out a file. Now to do that, we need to set it to Python mode. And the Python script will trigger a button press on the reload button on our interface every time it saves out, right? So as for the script, we're going to use the who.pwd command for our current node. So the node that got the button press, this ROP output driver. Then we're going to navigate up the network one level to the main asset using the // command. And then I'm going to reference the reload button on our interface, which is a parameter. So if we then reference the reload button, this one, or if we grab the parameter menu, here it is, we can then activate the press button Python function, and this will cause Python to press that button. So let's highlight this. That's the code we're going to use. So now if I go ahead and change my paths, then let's highlight this node so we see the results. If I move this around, and then I go ahead and save the data, you'll notice how the file node updates. So let's do that again. Let's move it around. This is what's currently our result. That's what the cache sees. If I go ahead and save, now my cache has updated. So that's the basic loop. So let's go ahead and move this up to the top of our network. And let's give it its own little netbox. I'll call this one the cache loading netbox. And now what I would like to do is take this network and make sure that it's snapped to the existing grid. So if there's a height difference between the terrain as it is and our data cache, I want my data cache to update so it matches the same height. Our grid won't change going from left to right or, in X and Z, but it might change in height, and I want that to match. So let's go ahead and copy our flattened network here that we created earlier. And I'm just going to replace this fuse node because I only want it to transfer the height. I don't want it to snap to anything. Let's delete that and add an attribute transfer. And we're going to call this one transfer height. And I want it to transfer the height attribute at a range of 0.01. So this will make sure that the value is set properly. Now, if I test this out, and I'm going to quickly deform my terrain here, and you see that the existing path coming from our cache is also updated. So our points should always be matching the points of the grid this way. So before we continue, let's go ahead and add another convert line here. So just in case our network is properly carved up before we feed it to the Pathfinder. And this is where the magic really comes in. If we feed this cached path back into our pathfinding loop, it will treat it as an existing set of curves, as if it was a previous iteration. And doing so means that our next paths are going to see our old cached paths as a potential input. So let me quickly remove the transform node here. And then let's have a little look. So now if I grab my controller, I can move it around and you can see how the Pathfinder actually snaps to the existing paths that are in the cache. And they're actually marked green as well, which is because of the visualizer we set up earlier. Now we still need to actually link up the save node here. So let's go ahead and create a new parameter on our interface. Let's grab the type properties window, and I'm going to add a new folder called editor here for this. This is going to have all the different controls for the save load cache system. Let's grab the save to disk button from the ROP output driver and drop it in here. And I'm going to call this one save segments. And let's call it save so we can differentiate it easier, because we'll have some other ones in here as well later for the removal and clear system. So now if I go to the top of the network, you can see that we now have a save segment button here. Now I don't like how these tabs are lined up, so let's quickly click on these and change them to simple tabs, for now at least. So they're all lined up. And we can make it a bit more fancy using drop-down folders, but we don't need that right now. But now if we go ahead and grab our curve, we can add new segments like this. And if we click the save button on our interface, we've now added new segments to our cache. So that's working. Okay, so now let's go ahead and create an extra output point for our paths. Right now we only have one for the visualizer. We need to add one more. So let's go in here and add a output node. And I'll call this one output visualizer. This is going to be output 0. And I'm just going to make sure the normals are correct too. So let's copy that one and plug it in between. And then up next to the load node, the file node, let's create a null node. I'm going to call this one output, and then drop a new output node below that. And I'll call this one output raw curves. And I'm going to make this one blue, so whatever comes out of the network is a set of data. So now we have two output dots. Let's plug this in because this will allow us to send our paths to Simon's tool. If we update the stash node, basically update our little buffer, then now, if we view the results, you can see that now our paths are represented in the world. So at this moment, we have the ability to add new paths using our path editor. And if we grab our curve editor here, we can add new blue segments. And then if we save, they will turn green. However, let's say we also want the ability to remove our sections from our cache. So let's copy our save add node and let's rename it to save clear. I'm going to snip the connection here and add a null node in front of it, which means that whenever we click this button to save, it's going to just empty our file with nothing. Now, if I grab this, I need to break the link to our interface because this is a new ROP output driver. And then I can drag it over into the interface over here below our save segments button. Let's rename this to clear all. And as for the name, let's also call this one clear. And then we'll apply it. So if I now go to the top of my network, you'll see that we now have a clear button, and that will allow us to remove segments from our grid, and then we can save new segments into it afterwards. So we can now add and remove our sections. However, the moment we need to have more than one mode, it's actually better to add a little toggle because we don't want to accidentally press this clear all button and wipe our entire data set by accident. So let's create a new entry here, ordered menu, and let's call this one tool mode. And then under its menu, I'm going to add 3 values. First one's going to be 0, that's going to be called add. Then we have 1 for remove. And then we have 2 for clear all. And then with that, let's go ahead and add a separator in between this and the buttons. And now I need to set up the buttons so they only show when their own mode is active. So let's go to the parameters, and under the hide when tab, I'm just going to type a little expression there. So for the save button, the add button, we're going to set it to if not to mode 0. And then for the clear all button, it's going to be if not to mode 2. So now you can see that we have one button on the add mode and one on the clear, but we still need to add one for the remove mode. So let's go ahead and copy the ROP output driver again. And let's call this one save remove. And I'm just going to add these to a little netbox so we can keep it clean. I'll call this one the save data netbox. Pretty straightforward. And to create a removal system, what I want to do is grab the cache loading information up here. And I want to make sure that this gets snapped to our existing curves. But to do this, first I need to actually have some curves to work with. So let's go back to the top level and quickly add a couple of them to our cache because I just cleared all of them, right? Let's drag this around and save it out. So now we should have some data to work with. Let's grab this, and what I want to do first is make sure that when I have any connections from my curve controller, I want them to snap to the existing grid. Because if they're not snapped, I don't want it to select anything, because I don't want to accidentally remove parts I don't intentionally select. Let's go ahead and create a fuse node here that we can use for a snapping feature. So just like before, I'm going to use the fuse node here to snap our input controller to the existing paths. Let's set the snap distance, so I'm going to promote this to the interface. And I'm going to call this the cursor snap strength. Let's add it to the Pathfinder tab. And the default value for this is going to be 5. And let's lock it between 0 and 10 for now. And we need to make sure that we set it to closest target points, otherwise it won't snap properly. Let's grab the output from our existing paths and branch it off into the second input. So now, whenever we have a curve, it will try to snap to the network if it's nearby. And next, what I want to do is create an attribute wrangle to verify if these points are actually on the network or not. So let's plug it in like so. So what this wrangle script is going to do is that if the point is not on an existing path, then we're going to mark it for removal. So we just need to write a little expression to check if this point is actually snapping or not. So let's say if the near point, or basically the point that's closest to our current point position, is within a 0.01 range, which it would be if it was snapped, then if it's not that, then we go and mark it as an unsnapped point. So we'll call this one unsnapped as a group. And then if we look at the groups over here, and then mark them, you can see that this point here is not snapped. If I disable the snapping feature on the fuse node, then the other ones will also be marked unsnapped because they're slightly too far away from the existing curves to be valid. So next what I want to do is just remove every point that is not snapped. Make sure we delete all the unsnapped points. And let's call this remove unsnapped. So with that, we now know if our points are snapped or not. And then we can just use a find shortest path node to create a connection between them. If we plug this in like this, where we have our existing segments, and then we have our points as our starting points, we can now use the asterisk symbol to mark every single point in our inputs as a start and end point. And what this will do by default is try to path between these points. But if you set it to the default setting, then the find shortest path node will just try to path to itself, because each point is valid as a start and end point, therefore there's no distance between the closest point, right? So we have to switch it to use each start to each end, and this will make it path from every point to every other point. This becomes heavy if you have a lot of points to path between, but in this particular case it's fine, because we don't have that many connections in our grid. It's a very simple network, and we probably won't need many points to delete anyway. So next, let's just grab a convert line node and turn this into a couple of separate segments. Then let's grab a clean node and make sure that we clean up any double segments as well. And now if we have this, this will allow us to delete the selected segments from our existing data cache. So let's go ahead and plug this in below, and we need to create a group node here and then transfer it over to our existing path network. So we'll call this one remove segment, and then transfer it just like we did before at a very short distance. So now if the path that the find shortest path node generates overlaps with an existing path in our cache, it's got to be marked as remove, and then we can just blast it away with a blast node. So let's go ahead and do that. And we'll call this one remove segment. And the reason I'm using a blast node here and not an attribute wrangle or anything, well, it's for simplicity. But this now works, so we can plug it into our remove output driver. And we need to make sure we hook this up to our interface as well. So let's go ahead and delete this connection. and then drag it over. And in some cases, you might notice that Houdini doesn't like that because you haven't refreshed the type properties menu, like here. So what you want to do is just close the type properties and try it again. So let's drag it over. And this will be the remove segment button. Plus, don't forget that you also want to make sure that you set up the hide when tab down here. So if tool mode is not -1, it should hide it. So let's click accept on this. And the last thing I want to do is just make sure we clean our data, because it's important when you have data going in a repeated loop that you make sure you don't add it with junk data or double it up. So let's add a group delete here and remove some of the groups that we've added. Managing your data in an editor like this, especially when you have a complex one, becomes very important. So let's go ahead and just set this to remove all groups. So I'm going to color those red because I like to color whatever deletes things red. And now let's go outside of our network and have a look at the features. If I switch it to remove mode, I have the remove button available, but we're still seeing the wrong visualizer right now because we haven't set that one up yet. But if we click remove, it will work. So you see it removes a segment. So let's now update the visualizer. I'm going to speed this up again because this is relatively simple. I'm basically just going to copy the previous network and color it red. So instead of the live segments, I'm going to use the remove segment, and I'm going to plug that one into the data up here, where it comes from the removal network. And right now the colors are wrong, so let's go and change the blue color, which is our selected color, to red. Let's grab this null node, plug that in, call it visual remove. And what I want to do next is just add a switch node, so we can switch the visual depending on our tool state. Let's grab the parameter from the top level, plug that in. And then our first input is the add mode, second one is the remove mode, and then the last one is going to be our clear mode. So let's grab that one as well. And for that, I'm just going to grab the full network, so we can use the existing link here coming from our removal network. And I'm going to color the entire network red instead. So if we're in clear mode, everything is going to be removed, so red means we're going to delete everything, warning, right? So now we have the network all set up and our visualizers too. And this is of course important because this allows our tool to represent what we're doing, and that will allow our users to understand what's going on. So if we test this out quickly, we can see that if we move our points around and wherever we have it selected, in between those parts, it's going to mark it for deletion. Now, there's just two last things that I want to quickly clear up before we finish. The first thing is that I want to grab my input curves for the Pathfinder and snap them to the existing curves, just like we did before with the removal system. So I can grab the snap control curves to existing path node here and then copy it over and drop it in over on this side. This should be set up properly. So you see how it can snap if we increase the snap distance. I'm just going to wire it up directly to the node up here for cleanliness sake. And then the last one is that we need to make sure we set up our show grid so it can be toggled on and off. Let's go ahead and plug that in here, turn it into a toggle, and I'll call this one show grid. Now by default, I'm going to set it to 0, so it's not visible when we load in the tool. So now we are pretty much ready. Let's go ahead and test it out. I can show the grid, so that works. If I plug in the bounding box, we only have it in this particular selection area. And now let's go ahead and draw a couple of extra paths. So in add mode, I can start clicking around. And this works. Okay, we can save them. Now let's try to remove some. Let's grab a section of this path and then remove that. And now the last thing would be to check the clear mode. So let's clear all our connections. And that works too. Okay, so at this point we have a functioning tool. Everything is working. Let's path across the map. And let's save this out. And then update our cache. So we send it over to Simon's tool. So now we can view the final result. And here we go. Everything works. It's all in the world. So that's the workshop part for the cache-based path editor. I hope it was clear for you. And let's go on to the next section. So in this next section here, I just want to quickly go over another tool. And that's basically a Python viewer state object editor. And this tool has the ability to take a data set, such in this case a set of instances that have been placed into this room configuration, and to grab it and move it around using a Python viewer state. So as you can see, I can just grab objects and rotate them and reposition them, and then when I'm happy with it, I can save it all out and it gets changed inside the data cache. So this is actually a very user-friendly and intuitive way of changing data that's already been generated before. So let's have a quick look at Python viewer state editors, right? Now I'm not going to go over the entire Python code here. That would go a bit too much in depth, and we already ran a workshop. But this is basically more about how to set it up. So this editor uses Python's viewer states and custom handles driven by the mouse. And it's a very user-friendly and interactive tool. And it's used to control data sets, to modify an existing data set. So it's based on an existing SOP node. If you're going to make a Python viewer state tool, you generally want to base it on an existing node and then add functionality from there. So in this case, I'm actually using the add SOP to create points, and then to modify them using the code inside the interactive section of the editor asset. So here you can see how we use the abilities from the add SOP to quickly add points into my screen. And over on the right, whenever I click, I actually add a new entry with the coordinates of that point, as well as whatever object I'm currently trying to assign. Now this set of information is basically written out to this multiparm and then instantiated using the rest of the tool. So the multiparm is just the base data, the list of data that I assemble when I use the viewer state. But then this information is then taken by the tool and used somehow. So in this case, whenever I click, objects are loaded from my hard drive based on the address that I'm currently trying to get. And then it's instantiated from the multiparm. So we also create a multiparm when we try to edit objects. These actually get stored in a separate multiparm. So if we have objects in our scene that are in the cache, or even new objects, these all have an ID. And we can then record which object we were trying to modify when we click on it with, say, the move tool or the rotate tool. And this creates a new entry in the edit multiparm with that ID. Then if we grab the object, the changes get recorded inside the multiparm. In this case, I can move the object based on my cursor position, or I can rotate it if I switch to the rotate mode. And The way how this works is by storing at all times the current cursor position down here in the cursor entry. So I know where the cursor is, and it actually hits objects in the scene, and it records that position where the raycast hits. And next to that, I'm also bringing up to the interface if I'm pressing the left mouse button for clicks, if I'm holding the control key, or if I'm holding the shift key. And I can use this to modify the behavior of the visual elements of the tool. If I hold the control key, my cursor turns darker. And if I hold the shift key, I get this move grid. So I actually ignore the vertical movement altogether. So next we have the ability to use the scroll wheel to quickly switch between modes of the tool. So we have the move mode, the up and down move mode. We also have rotation, and we have the ability to add new objects from an FBX file or to mark existing objects for deletion. So these different modes, normally you would have to go into your interface and click the button, but by binding it to the scroll wheel, we can quickly switch the tool to different states. So like I mentioned, every object in our scene has a particular ID, in this case the primitive number. And when I move the mouse over an object in my scene, I can read out its ID and store that information on the interface. And this is very useful because this gives us the ability to create visual feedback. The ID is applied to whatever object is currently in my scene and given a different color. So when I move my cursor around, I can see visually what is actually being selected. And this is also important to then read out information from Python, but I'll go over that in a minute. Now here is a little overview of how everything works combined. As you can see, I can grab and move objects. I can add new objects as well. And then when I'm happy, I can apply those changes. Now, every time I move an object, the changes get recorded to the multiparm. And then those changes get applied to the original cached point data. They override the particular point that the edit is made on. Then, when I'm happy, I can save out these changes back to the cache file, and this triggers a reload on the load node, on the file node, that loads this cache file up top, like I basically showed you in the workshop. So this feedback loop allows me to edit objects. So grab an object, move it, edit it, and then save it back out in a very rapid way. Likewise, if I don't like my changes, I can also simply click on the clear all button, and this will purge the multiparm list, and we're basically just back to an unedited pure version of the cache. So it's actually really important that the Python viewer state and the parameters know which current ID to modify, because the node uses the multiparms to create new data. And if we start writing out to the wrong multiparms using a Python state, we can actually break the tool's workflow. So in order to make sure this doesn't happen, we need to make sure we always synchronize our Python viewer state and our parameters. In this case, I only really need to sync the ID that I'm currently selecting, that's currently under the cursor. So like I mentioned, when the Python viewer state reads an ID from the geometry underneath the cursor, we then take this ID and set it on the interface. Then we use this parameter to drive the visual feedback elements, so us as the user can see which object was last modified or selected. But then Python will also sync its own internal variables from the parameters on the interface. So this means that Python writes out to the interface and then reads it back in to update its own internal variables. And now Python is using those internal variables for the internal code. By making sure that we sync the Python viewer state to the parameters, we actually avoid Python from throwing a lot of errors. And errors will break your tool, they will break your workflow, so we want to avoid those. So creating a very secure system for this type of tool, because we're interfacing both between Python and our node network, is very important. Now the last thing I just want to explain is how we can keep our tool working fast when we are dealing with FBX files. Because loading FBX files, especially if you have a lot of them and a lot of variety of them, is going to get heavy. In this tool, I actually created a cache loader that has a standard FBX file loading loop, just for each loop that loads an FBX file for every single unique object. But then below that, I have this stash node installed. And the stash node caches all the objects that are being loaded from the file node to memory. And then the rest of the tool just loads the objects from there and copies them to the points in the scene, to the instances in the scene. I only have to update this stash node whenever the information coming from the stash node doesn't match the information coming from my objects in my scene. And if there is a difference, then I can make Python cause the stash node to recook. That's when it updates the files, and then the stash node has the new data. So this creates a more staggered way of loading your files, and it makes the entire memory system a lot faster. So you can actually have an interactive viewport interface without constantly updating your file nodes, which is really slow. So with that, we've pretty much come to the last part of this workshop. And before I continue, I quickly want to recap some of the things that we talked about. So the first thing that we did is talk about procedural pipelines and the types of tools and methods that we can use to build them up. And I've highlighted some as examples as well. Then we went over how to make a cache-based path editor using a save load system and a basic pathfinding setup. And then lastly, we broke down how to build a Python viewer state based editor to take objects in a cache, move them around, and then save the changes back to that cache. And I just wanted to highlight that because during the course of this workshop, we actually covered several parts of my procedural asset production masterclass. Both parts that we talked about, such as the pipeline, but also the drawing systems and the Python script-based viewer states. They're all part of my masterclass. And I just want to talk about that a little bit. My procedural asset production masterclass is a large, comprehensive, multi-stage course that will teach professional digital asset development for game development pipelines. And I'm focusing on the Unreal Engine and world building type tools. We will start with basic beginner level canned assets, such as the elevator and staircases that I've shown, but we'll also move later on into much more complex tools, and we'll build this large high-rise building. Now over here, we have the Masterclass Introduction module, and this is the first module of the course that aims to teach complete beginners to Houdini, the basics of procedural modeling and texturing, and then the ability to bring this into Unreal using the Houdini engine. And I'm now seeing right here that with Houdini HIVE, this is being launched completely for free. And I'll give you the links in a minute. So first, what I want to do is show you the trailer to give you a better overview of what this introduction module is going to be about. So today I'm launching the first module of the masterclass, and this one contains two parts. The first one is called Houdini 101, and will cover the basics of Houdini. So this one's for complete beginners to the program who know nothing about Houdini at all. And then the second part is called the foundation module, which will give you a good, solid foundation for working further in Houdini. We'll teach you basic procedural modeling, as well as basic procedural texturing and instancing, so we can bring this all into the Unreal Engine 4 and build this building you can see down here. So the upcoming modules of the masterclass will cover other procedural tools as well that will later hook together to form a much larger project. So over the course of the next year, I aim to release 5 more modules for this course, each one teaching you different aspects, and will cover things such as elevator builders and staircase builders in the next module. We'll also be working on a catwalk builder, a procedural tile builder and instancing for the outside of our structures. We'll be working on a freeform building editor toolset for creating complete high-rise buildings with floor plans, internal layouts, corridors and rooms. And then we'll be working on procedural prop placement tools, which start with manual prop placement tools such as the editor that I've shown you earlier, but also a complete procedural preset-driven placement system that we can just drop down on a room and it will lay out complete hotel rooms and restaurants and any other type of layout that we've previously defined. Plus, during the course, we'll also be developing several powerful utility assets that you can use in any of your projects. And the entire course will come with the example files and the Unreal project files combined. During the course of the actual masterclass, we'll be covering several different topics, including how to use instancing in Houdini and integrate it into the Unreal Engine 4. We'll cover advanced pathfinding techniques using the Find Shortest Path SOP and its many powerful capabilities. We'll be going deep into Vex and Python, as well as Python viewer states, in the final parts of the course especially. We'll be covering procedural pipeline design as a whole. This entire course is all about integrating tools together and making powerful tool sets. So this is definitely one of the major parts of the course. Next to that, we'll be building advanced editors that are very interactive and easy to use for users. And finally, we'll be covering some batch processing as well, so we can automate some of the tasks like generating the tiles for our building. So if you want to get started on the course, you can find it right now on my channel on YouTube under eHoudini Academy. And if you want to learn more about my masterclass, you can visit my site at www.ehoudiniacademy.com. Next to that, this masterclass is only possible because of the support from my Patreon backers. And over the last year, I've had several dozen people join me on Patreon, and they've helped me develop this course, buy the software I needed and the hardware I needed to record all the content. So thanks to my Patreon backers, I'm now actually able to release this first module for free for everyone. Now, if you choose to become a patron for my project, you will get basic updates every day on what I'm doing that day, as well as weekly progress updates as I develop the course. Also, long-term backers and higher tier backers will over time accumulate discount credits for upcoming modules, which will of course provide you a discount whenever a module is released. And finally, I also offer mentoring and student guidance on my Discord channel. So if you're interested, please check out my Patreon site, and you can also read the FAQ on what it all means and the different tiers that are available. Of course, if you just want to join the community of eHoudini Academy and follow me on my Discord channel, feel free to join there, or you can check out my Twitter in order to get updates on the course whenever modules get released. So yeah, thank you everyone for following along with this workshop. I hope it was informative, and see you out there. Have a good one.